Good morning, and welcome to the first of the 2026 Open Data and Open Knowledge sessions. My name is Leo Chilwane from South Africa, and I'm one of the co-chairs of the GEO In Situ Data subgroup. I'll be your moderator for this session. So over the next 75 minutes, we're going to spend our time with what is arguably an indispensable layer of Earth observation, and that's in situ data. The measurements taken on the planet rather than off the planet from orbit. So think about it for a second. Most Earth observation products you've ever trusted, every map of sea surface temperature, every land cover classification, every air quality alert has been or were calibrated and validated against measurements taken by a person, an instrument, or a community somewhere on the ground. So without that in situ backbone, the view of Earth observation is incomplete. And yet, as those of us working with in situ know, and as acknowledged by the GEO community in general, the sharing of in situ data remains limited, fragmented, and full of gaps. So that's the problem we're trying to tackle in this session from 5 complementary angles. So I'll just give you an overview of what you're going to hear today. So we've got 5 speakers, the first being Alessandro Turco from EPOS ERIC, who will introduce the ENVI Hub next, the European Environmental Research Infrastructure Cluster's effort to create a single fair entry point to essential climate variables across 27 research infrastructures. He will also highlight the ENVI Hub's integration pathways with the GEO Knowledge Hub. This will be followed by a talk from Alba, who's going to present the Geospatial In Situ Requirements tool. So GREX is a structured way for users to tell GEO what they actually need, where the gaps are, how precisely they need to be filled, and what is blocking access today. Then the third speaker will be Francesca Piatto from the European Association of Remote Sensing Companies. Francesca will present Enforce, a Horizon Europe project that harnesses citizen science and innovative technology to bridge the gap between locally collected environmental data and the standards required by public authorities for compliance monitoring and enforcement. Then the fourth speaker is Eleni Athanasopoulos. I hope I haven't butchered your name, of the National Observatory of Athens, and she will be presenting a synthesis of 4 Horizon Europe projects that between them illustrate what innovative non-space observation looks like in practice. The common thread here is a lesson about what it actually takes to keep instruments running autonomously in harsh places on budgets, and how these deployments are scaled. And to close off the session, we'll hear from Helen Glaves, a co-chair of the In Situ Data subgroup. So Helen will take us through the In Situ Data strategy and set out the strategy's pillars and the roles the strategy proposes for GEO going forward. So her talk is the one that presents a community-driven framework for the technical work we're discussing today. So in closing, we'll hear about a hub, a requirements database, a compliance framework, a portfolio of field deployments, and a strategy, 5 pieces of information on the same puzzle. So after the talks, we hope to have an interactive Q&A. So please jot your questions down as the speakers take us through their presentations. So Alessandro, over to you to present the ENVI Hub next. Thank you.
Thank you. Do you have the tool for the slides? So, good morning, everybody. I'm Alessandro Turco. I'm very happy and honored to be here in this GEO Symposium. And I'm from EPOS Eric, but today, if I manage to move the slides, sorry. Okay, so today I will wear my Embry hat, and I have to thank the Embry Hub Next project coordinators that trust me to give this presentation to you and to explain what is Embry, what is the Embry Hub, and what is the work in progress for the integration between the Embry Hub and the GEO Knowledge Hub. So this is me, so nothing very interesting for you, apart from a couple of things. First of all, it's just only a couple of years that I'm in this field. Previously, I worked in a private company, a software company, so be patient with me. And the counterpart of this is that maybe I can have some fresh ideas or point of view on the topic, and I don't know if this will be a silly idea or not. That's up to you to judge, and please give me your feedback afterwards. So indeed, I'm going to have to present a community, the Embry community, that of course is made by 27 research infrastructure. It includes 4 environmental domains, and it has been founded by several EU projects. You have the list here, and we are already preparing new projects for the cluster. But the truth is, Embry is a community of people, and my idea is that good things happen when good people are working together, and they are working together in a good way. Just a brief thing, I was at EGU a couple of weeks ago in Vienna, and one of the main topics there was data resilience, and I was expecting to hear a lot of technical discussion regarding redundancy of databases, high-speed connection, geopolitical things, but what impressed me in that conference, and this is the main message I want to bring you today, was that at the end of the day, the most critical element in all the data resilience problems and solutions that were presented was the human element, so people. And the fact that if a person is missing for whatever reason in a critical position, it's much more difficult to replace this person rather than replacing a database, replacing an observation tool or whatever. And that's the same idea for the Embry community. So there are the research infrastructure, the European projects, but the reality is that there is, and it's growing, a very active and collaborative group of people that will continue working on 4 environmental domain to bring together data, services, and anything that can be used by scientists in this field. So the Embry Hub Next is the current project, is a project that has a very specific objective, so to renew and offer a single entry point, a unified access to environmental data, thanks to interoperability framework with a strong focus on essential climate variables, because of course nobody can do everything, so we decided to focus on the most important element that has been recognized worldwide, so the essential variables. And we are doing this in the open and fair way, like it's I would say mandatory for advancing science, with the most recent technology. So the cloud-based nature of the portal is paramount in this. So The Embry Hub next project hasn't finished yet. It will finish next January or February. But the Embry Hub is already in production. So you can either go to this website or scan the QR code and you will be there. And you will find let's call them macro services that you see in this slide. So a catalog of services, a catalog of data, a catalog of training, a knowledge base that works together with a AI environmental expert, and the programmatic access to the Embry Hub services. Let's dive a little bit in this. So I think that I do not have to explain to you the essential variables. I think that everybody knows them better than me. Anyway, they are defined at global level. Some of them are simple variables, so directly linked to observational measurement. Some others are more complex and they require different variables to be put together. This is to explain the complexity, and our answer to this complexity was to enforce the use of standards and to homogenize and harmonize the languages spoken by the different elements. So for dataset and services, we use the EPOS DCAT EP profile. For ACV metadata harmonization, we work with iAdopt and the NERC vocabulary server. And since I have a very short time, let's go to a very quick workflow within the hub. So the user may start with the knowledge base. The slide is empty by purpose because I want you really to test the hub. So go there and try the knowledge base. In the knowledge base, you have a search engine which will provide you a lot of resources. Is somehow to some extent similar to the GEO Knowledge Hub with the structure, just to explain to you how it works. And on top of this, we built an environmental expert that is a dedicated AI-assisted chatbot. So it's not ChatGPT, it's a model trained exactly with the elements we have in the knowledge base. So it's very specialized on the topic. We have the catalog of services that is built upon the EPOS open source platform, where you can visualize, you can look for data sets and visualize them in the map just to advance your knowledge and to have a first preview on the data. And then we have the analytical framework that is a Python library that wraps the catalog of services and returns values and any other help functions into a Python environment to analyze the data in a single way. Now, this is what is the Embry Hub. Now the Embry Hub is moving forward. Let me do my institutional part of the job. So I want to highlight once more the fact that the catalog of services is built upon the EPOS open source platform. And this is important because it's open source and it can be used either in also in other contexts. So if you want a map-based interface to show your data, you can go to the web page of the EPOS open source platform and plug in your services and your data. This is included in the Embry Hub, and the Embry Hub now is moving towards a EOSC node. It has been enrolled for the second wave of EOSC nodes, and we are working, and that's why I'm here, together with the GEO Knowledge Hub to exchange data and services. We foreseen 4 pathways. We have a prototype for 2, and we are working on the remaining 2. So this is the first one. So from the Embry Hub, from the catalog of services to the GEO Knowledge Hub. So thanks to the harmonization work we have done in the catalog of services, together with the Python library, and thanks to the work of the GEO colleagues, it was possible, and I think, relatively easy, you can comment on this later, to retrieve the services in the catalog of services within the GEO Knowledge Hub. I suppose this is a staging environment, not the production one, but still this proves that the linkage is possible. Vice versa, from the Embry Hub point of view, we managed to harvest and to index the content of the GEO Knowledge Hub inside the environmental expert that now is able to answer specific questions regarding the GEO Knowledge Hub packages with hopefully the right answers. It's up to you to try, and if you find any errors, please report them to me. The other two pathways, to conclude, are from the GEO Knowledge Hub to the catalog of services. So some packages in the GEO Knowledge Hub has a data set within them, or they include services to access the data. And we would like to have a metadata mapping between the GEO Knowledge Hub and the Embry catalog of services, so that we will be able to list also those services if the governance and all the back-end requirements are fulfilled. But we still we want to start from the technical assessment of this. And the last one is to have the vice versa indexing, so from the Embry Hub knowledge base to the GEO Knowledge Hub, so to have more content available also in this platform. That's it. I hope the time is good. So thank you, everybody, and thanks again for the invite.
Thank you so much for that, Alessandro. And just a note, if you have any questions, please note them down. We'll take them at the end. But thank you for that presentation, and it highlights how you're enriching the GEO Knowledge Hub with content. So next we'll hear from Alba, who's going to present GREX. So this is the way you can tell the GEO community on what in situ data you need. So Alba, whenever you're ready, over to you.
Thank you. Thanks a lot for the introduction. Hello, everyone. Okay, I will try to. So I'm going to present, as mentioned, the GREX, the way you can tell us what in situ data you need. So, this is an agenda. I am going to, to present the tool in a nutshell, and then the progress that we have done, and the different pathways and examples that we can show, and then all in all, input for the GEO in situ data strategy implementation, and also the progress on the integration of GREX in the GEO infrastructure. So for the people in the room that doesn't know GREX, GREX is the Geospatial in situ requirements. Is an open database tool, standard methodology for capturing user-driven needs and requirements for in situ data, especially within the GEO context. And among the objectives, GREX allows to identify technical barriers to data access and use, reveal gaps in spatial temporal coverages, and then with the information gathered, we are able to make recommendations for in situ data improvements. We turn the focus to the data users' demands, as has been mentioned in the plenary before. And all in all, also to inform observing networks and data providers, and to support the implementation of this GEO in situ data strategy. In summary, the GREX data template. So what a user GEO activity participant needs to do when going to the database. So first is asked, why do you need in situ data? Because in situ data is needed for many other things beyond calibrate and validate remote sensing data. No? So the user starts thinking on which is the need, and then is able to provide the characteristics of this data that is required, no? In terms of area, the essential variables, and many other aspects of geographic information that all of you know, but these details are very important to us to then work upon them. And for now, the database has more than 100 requirements and more than 20 geoactivities represented, and we are doing this work since 2023, so yeah, almost 3 years ago. And the process, how to contribute. If some of you want to contribute in GREX, and you have not been already contacted by me. So you know that we offer our availability to conduct these guided telcos where we provide support to the users to document all these requirements. That is not straightforward, but it's not so easy as one can think. And of course, we can then discuss via email and so on. We have resources in our, for instance, new website, and where there is the open requirements database and the submission module when you on your own you can report these requirements. And if you want to know more, there is a poster outside and you can come and talk more. Okay, I don't know the time if it's good, but now I am going to explain that in the left side of the slide, we can show the process that we have been doing, collecting all these in situ data requirements. Then in the right side of the slide, we have the different pathways, the different approaches that we can do, we can act upon on this information. If there is a new sensor or perhaps a provider that the user already didn't know, or barriers or gaps identified. So let's see some examples on how these pathways, how we are working on this from the requirements hosted in the GREX database. This is a first example, use case. So GEO Human Planet requires data on construction materials of buildings for disasters risks assessments in human settlements. And so they have explained it to us that they require this kind of specificities about these construction materials of buildings and all that characteristics are there. Then, sorry, because I don't see very well the slide, but I will try. So, and then we have worked on this information. We have researched it. So we have found that cadastres, official censuses, and household surveys are the main sources of this information. So public data. Then nighttime light products that have been mentioned before in the plenary as well are very used for mapping human settlements, but not so useful in this case. And then urban plans, we also realized that urban plans, the BIM, the building information modeling, information that is generated during the construction of a buildings or a neighborhood or so on, and that it is not well preserved. So we have been able to extract some recommendations from this. And so for the Commission or whoever needs to give funding, promote projects that harmonize BIM and GIS to better preserve the geospatial data about the built environment, and also improve this coordination with cadastres and municipalities. This big issue. And so this is one of the examples. I am going to explain another one. We have here the case for the geoland degradation neutrality. One user on behalf of this activity has explained it to us that that has requirement on flux towers measurements. Because for monitoring the SDG land productivity indicator, so has provided to us some characteristic on the data that the user asked, in this case for the net primary production and gross primary production variables extraction. So which is the current data landscape sources and limitations? So we see that there is a lack of coordination, even if these measurements are more or less well coordinated, but FluxNet, but however, more coordination is needed. And perhaps this data is available, but is not in perfect state as we can imagine. Currently, it's nice to point that there is the Mona Lisa European funded project that currently precisely is looking at to discover if there are enough towers, we need more, they are well distributed, so this kind of things. So our recommendations is, in this case, we were able to make a kind of calculation not on the data that the money resources that are needed not to harmonize, to create an harmonized product of flux measurement, and you can see here the results. As I think that the time is not 2 minutes. I will skip this other example, but we have more, and we will put these examples on the website. So if you are interested, please. But here at the end, these 5 squares is because we with G-REX, as we are extracting information for the GEO, we think that these can be inputs for the implementation of the GEO in situ data strategy. And so the first already have been explained that, but here is to highlight different topics, different kind of things and issues that came up. For example, the third case about the maining activities, the involvement of citizen science and universities in areas in the world that are perhaps, that is difficult to access to this data also from remote sensing, because the satellite cannot see, because the canopies, because the clouds, because there are activities that move very fast. And then in this green one, sorry, I will finish right now, but this green one, from the GeoBond, so this importance of the ecosystems and the biodiversity monitoring, we have been aware about this new EVOC center, and of course the integration of the not only the EMBRIS but the other research infrastructures is also a thing to take into account. And finally, also a case where a new sensor, low-cost sensors could fill some of the gaps that in this case on the solar irradiation domain still exists. And so the pathways here more or less demonstrated, so that sensors, if there is a sensor that can fill some gap, yes, and then the others, some barriers identified, some gap, and then of course the providers for this matchmaking, as most of the users we work with, and they are experts from long years, so we are not still not approaching this pathway so far. And finally, the G-REX, we know that has been started to be integrated in the new GEO infrastructure. Thanks a lot, because we were very happy to see these tests, and and we are looking forward to see more and continue working in this, because we have more years funding to work in G-REX. So so we will continue here. Thank you.
Thank you so much, Alba, for that. Your work really is helping us understand the needs of users and how to address them. So next we'll hear from Francesca Piatto from the European Association of Remote Sensing Companies, and she's going to present Earth Intelligence for Environmental Compliance, so integration of Earth observation and citizen science through Enforce. Francesca, over to you.
Thank you very much. Can you hear me well? Yes. Thank you so much. So my name is Francesca Piatto from the European Association of Remote Sensing Companies. And today I'm going to talk about Earth observations and citizen science through the Enforce project, and how this project support Earth intelligence for environmental compliance. That's great. So a quick word about our associations. We are a membership association in Brussels, not for profit. We represent the Earth observation downstream private sector. Across Europe, we currently have more than 130 EO companies actives and registered in 25 countries. And we represent this sector across the full value chain, from data acquisitions to the final service. So I'm very happy today Indeed, to speak about Enforce, which is an Horizon project which really wants to close the gaps between citizen science and environmental compliance monitoring, as it is a very big topic right now on how to transform a large amount of environmental observations data into trusted evidence that can support regulatory actions. Citizens collect data and observations into many through many in many ways, from community monitoring, mobile apps, sensors, documentations, and so on. But it is still very difficult for authorities to really make use of this data, right? And to integrate, especially them, into authoritative workflow. The challenge is not about having more data, but rather how to make this data more robust, traceable, interoperable, and legally usable. I will really focus on legally usable because this is also the main point of the environmental compliance in this project. So the response from this project is really make sure to integrate citizen science data, Earth observations, and AI analysis, building different methodologies and tools to really make sure that we can increment the quality and usability of citizen-generated data for environmental monitoring, compliance, and enforcement. This is done through different case studies across Europe, across different environmental contexts and challenges. So from water, waste dumping, biodiversity, water quality, forest management, urban pollution, and all of these case studies has the same objective. So really understanding how citizen data and Earth observations can support environmental compliance. And this is where the framework and the concept actually of the data readiness level appears in this project. I had the opportunity already in February during the sessions of ODOC to already start presenting also through our main partner this legal framework, which is now ongoing. And this is a framework that was developed already in the past for information technology, really to assess the health and the usability of information systems, and then has been, let's say, adopted and extended by Enforce, really to assess citizen-generated data and EO data together in terms especially of what we call fitness for purpose for regulatory use. Because in terms of, for us, it's very fundamental because the required level of data maturity really depends entirely on the usability of this, of how this data will be used. So this framework really is central because it provides a structured way to assess how environmental observations evolve from collected citizen-generated data into valuable environmental data that can be useful, especially at legal level. Here we can see on the top bottom the different scale of data readiness level, which is divided into different phases from sparse and validated citizen data to the final one, which is applicability, where the data is actually usable for judicial use. And this data readiness level scale also works with integrated criteria that you can see here, because as much as we want to use the data, if the data is has a very low, let's say, data readiness level, cannot then be used for specific requirements. A specific case study that I want to use this is really to show how the data readiness level then can support, for example, frameworks directive, in this specific context, the Water Framework Directive in the Devon region in the UK. Here is where it's very important, the data readiness level, especially the final step, the data readiness level 8, because this is really where Earth observation comes in, and is essential used for independent, continuous, and spatially consistent evidence that can validate what the citizen can actually see on the ground. And this connection is really what we see in this case study, because about its agriculture and water quality management in this region. Under the Water Framework Directive, member states are really compelled to maintain very a good ecological status of the riverbeds, but it's not really easy in concrete terms, in the sense that usually agriculture and sewage pressure really tackle these river systems, and also the regulatory monitoring is not that easy to do due to scarce, costly, and sometimes frequently in situ sampling. So there is really a gap in the monitoring gap between what the actual framework directive wants the member states to reply on and what the actual realistic measurements we can get on the ground. So within this case study, for example, these connections between citizen science, Earth observations, and an AI to monitor and to run the, let's say, patterns, for example, of erosions or pollutions, really, let's say, bring all of this together, and especially supporting this, let's say, data readiness level from less validated to a more applicable environmental reports that people can also, or citizens can use at legal level. Yes. In order to conclude, as well, we see how we can operationalize the data readiness level framework through the Final Plaza toolkit. This is still under development. And it's really a way where we can bring together all the different typology of data and services. Here in this plaza, we can really see where how typology of personas can really access it and use it and make sure that they can report, for example, environmental crimes that they feature, for example, that they see in their own countries. And they can log in by identifying themselves as citizens, as policies, as analysts, as regulators. And from this, by injecting all the different informations and data, they can actually prepare a report. And this report will really be developed and attached with a data readiness level, which we will show the readiness as well of this report and how it can be shown at different stages, from court hearings or to different setting. So for us, this is really important. It's still under development, so we're still running some tests. But we really think that for the moment, it can really provide a legal way to really make a concrete assessment of this data. And to conclude. What I wanted to say is that I had the opportunity already in February also with Ellen and the team to showcase Enforce as a project where really the citizen science in situ and Earth observation and typology of data can really support as well the future GEO in situ data strategy, but also in conversation as well with our project consortium, also understanding how the Enforce project can actually also benefit from this GEO work program and the GeoKnowledge Hub, for example, in terms both of discoverability, different capacity building supports, of course, disseminations. But then I'm very happy to see as well, also through the different presentations as well of how, for example, GREX could support or repos in this sense. So I think that I will also be very happy after these presentations to go more into details of this. So thank you very much.
Thank you so much, Elaine, Francesca, for highlighting that citizen science element. It's often underappreciated. So now we'll hear from Eleni Athanasopoulou from the National Observatory of Athens, presenting innovative non-space Earth observations to resilient decisions around climate hazards and waterland services.
Thank you. So I am Eleni Athanasopoulou. Hello to all. I am a research scientist at the National Observatory of Athens. But here I am first because I participate in a European project, Sirocco, and one of my tasks there is to make the liaison between GEO and activities and the project. But then I am also here as an ambassador, let's say, to transfer the cooperative experience to the broad community here, strengthening the in situ component of Europe and beyond, because as you can see there, contributors to this presentation are four projects that are relevant with each other. I will explain more later. And I also want to thank the representatives, Zhen Zhu, Rolf Ruffenacht, Nick van der Giesen, and Chrysoula Papathanasiou from all projects and institutes that have provided material for this presentation. So if you remember, in 2019, in the ministerial summit, with respect to observations, it was highlighted that there are both spatial and temporal gaps with respect to environmental information, which was also mentioned and recorded, let's say, in the Canberra Ministerial Declaration. These gaps and this request was addressed by the European Commission that were interested to fund projects that are relevant to new technologies from non-space, so ground-based, and that wanted to explore the climate change impacts. Several projects won these funds, and their commonalities, let's say, are cost effective. I will mention now some keywords that are relevant to all 4 projects: cost effectiveness, sensors, poorly observed or harsh or remote environments, operationalization, and climate change adaptation and mitigation. Coordinated by Sirocco, we created a cluster of these projects that it is named DL cluster. And what we want to achieve by clustering is to foster collaboration among all scientists and projects, to share our knowledge from working and implementing in the cases, and of course to amplify impact with respect to climate change, which is a global issue, and joining forces is always beneficial. Okay. So, a few words about its project. UAWOS is a project named after Unmanned Airborne Water Observing System, and they have developed a drone-based water observation system that provides hydrometric information over rivers. Then EULIA project, the acronym stands for European LiDAR Array for Atmospheric Climate Monitoring. And again, they have developed a low-cost ground-based LiDAR that it is also easily transportable and measures atmospheric information in the upper atmosphere up to stratosphere. Then it is Tempo Africa, transformative environmental monitoring to boost observations in Africa. Again, cost-effective sensor networks and support flood early warning systems, so they support services with respect to floods, reservoir management, and crop germification insurance services in sub-Saharan Africa. And then it is Sirocco, that enhances the in-situ environmental observations across undersampled deserts over Europe and Africa. This year's theme of our convention here is investing in Earth intelligence for a resilient future. So I tried here to highlight the components of the scope of this meeting that we are doing here in Geneva. I have selected some highlights here from each project. This does not mean, of course, that, for example, Sirocco or Tempo Africa does not produce open data sets, but as I said, I have highlighted some contributions. So indeed, UAWOS provides open data sets with respect, as I said before, to river observations. Then, with respect to interesting user stories, of course, all projects provide, but EULIA could provide some from Norway and France with respect to the field deployment of their LiDAR. As I said before, Tempo Africa focuses on neo-to-benefit solutions because they are focusing on 3 solutions. And then with respect to Sirocco, I need to highlight the collaboration between the research and the private sector. So in the consortium, private sector is present, and they are manufacturing the atmospheric measurement system for the desert areas. Now, I have interviewed these people representing the projects, and I have asked them 3 questions. The first one was which types of instrumentation you are developing, and which data products or tools you provide that that can support broader in situ initiatives. As you can see here, answers are relevant to the drone-based hydrometry, to networks of autonomous, as we said, LIDAR measurements of the upper atmosphere. Then we have local sensing nodes, actually 6 or 7 different sensors that monitor flood information, flood relevant information. And with respect to Sirocco, several environmental parameters, either meteorological or air pollution. And all these data are open and available. You can see with the yellow colors where this data come from, and of course these are valuable for the broader community. The next question was relevant to on if we do public sector partnerships, and with respect to answers, as you can see, with respect to rivers, the hydrometeorological survey departments and water resources authorities were collaborating and actually responsible for the demonstration cases in the 6 rivers of Europe. In the case of Norway, Germany, and France, and the LiDARs to measure upper atmosphere, there was it was not in the partnership of the project, but there was a dialogue and coordination with the local authorities to install and operate the instrumentation. With respect to the flood early warning systems, there was a collaboration with the Kenyan Meteorological Department for these 2 counties that the system is already working. And in the case of Sirocco, not only in Cyprus, but also in Serbia, we have in our partnership local authorities so that the network of sensors is installed and then operated and maintained. Third question had to do with challenges, which I think it is a lot important with respect to environmental monitoring with low-cost in situ sensors. They have reported the challenges, but I mean, I have separated them by project, although I think that most of them are common. For example, you see extreme weather conditions, either it refers to the upper atmosphere, or it refers to the riverside, or it refers to, they refer to the desert areas. There are operational challenges, not only construction, I mean, challenges. In case of Africa, where the resources, either by humans or by funds, are limited, this was indeed a challenge on its own. And with respect to Sirocco, we found a lot of communication challenges between the sensors and the transmission system. And because the areas are remote and you need to have a multi-connectivity system in the infrastructure so that this can support the transmission of data. And also, it was a challenge to see what are the trade-offs between cost and accuracy, or between running the sensor continuously versus autonomy of the system. And how to have a long-term reliability with respect to quality assurance and quality control of not only of the data, also of the sensor. Last question had to do with replication and scalability. And indeed, all projects have produced systems that can be replicated in similar areas. You see, for example, that in any ungaussed regions, the system of UAGOS project can be introduced and implemented. I have to run, I think, so I will not read and explain everything. As you can see in the case of Sirocco, the system is modular and expandable so that more sensors or more, or more atmospheric parameters can be measured. Here, what I wanted to do with the outputs from those interviews is to explore the GEO in situ strategy in conjunction with the outcomes of this cluster. So you can see that indeed there are common design requirements, there are open and new and open data sets. All projects have shared knowledge with area managers, local decision makers, or customers in the case of Africa. A lot of common operational challenges with respect, for example, to extreme weather, or with respect that all challenges are relevant to the regions that are all remote, and of course human factors. I asked them also to share a word from their experience up to now. And here you can see that Chrysula, for example, from the Sirocco, mentions indeed these common challenges that scientists face from the alpine areas to the desert areas. How important is to have electronic sensing in areas like sub-Saharan Africa. Then how important is to design autonomy in the first place and not add it, leave it as an added on later. And then last from Zen, the integration between EO and in situ data. That was all by my side. As I said, I am here as an ambassador of this knowledge. So you can find here the contact information of all people that have provided this valuable material. They were also convening together the previous weeks in the EGU, and we plan to convene again together virtually through a webinar so that they can respond to questions with respect to in situ monitor, not in situ, ground-based monitoring. That was all by my side. Thank you.
Thank you so much, Eleni, and thank you for sharing thoughts on alignment with the GEO in situ data strategy, which brings us to the final talk by Helen, who's the co-chair of the in situ data subgroup. So Helen will present the in situ data strategy.
Thank you very much, Leo, and thank you to all of the previous speakers who I think have set the foundation for what I'm about to say about the activities of the in situ data subgroup and the work that we've done to develop an in situ data strategy. I have to say that this work has been very much a bottom-up activity that has been supported by the whole community. So this has not been a small group of people in GEO. This has been a truly community consultative activity. And we have confidence that the strategy that we have arrived at has very much been a reflection of the input that we've got from a whole range of different people, including a number of the people who sit around me today. So I'm going to say a little bit about the in-situ data strategy. I would urge you to read the document because I very much am going to give you an overview of what are the most important points in the document. So just to lay the context of why have we developed this strategy and what was the mandate that was handed to actually the Data and Knowledge Working Group and the in-situ subgroup. In-situ data has become a priority for GEO over a number of years. And in fact, as already mentioned, the Canberra Declaration specifically identified the need for GEO to have a strategy that related to in-situ data. So in fact, indeed, in the ministerial statement from the summit in Canberra in 2019, it specifically calls on the GEO community to develop this strategy that addresses challenges in the area and also demonstrate progress in implementation. I think what we've already heard here this morning demonstrates the fact that the in-situ landscape is in fact very diverse and very complicated. There are a range of different disciplines with different data acquisition activities, and this is actually creating a very heterogeneous landscape that we need to think about how do we integrate all these diverse activities for the benefit of the whole community, but also to serve the GEO priorities, particularly those set out in the post-2025 strategy. At the moment, the efforts to create and adopt standards are actually limited, and there are actually a number of significant gaps in the areas. So this morning we've heard about GREX, where we've been thinking about what are the requirements and also the gaps look like. We've heard about efforts such as the ENVRI Hub, which is trying to bring together this landscape and to actually integrate a number of the different data acquisition activities. But the first question that we've had to address is, what is the actual value of in-situ data? So why do we care? I don't think anybody in the room would be surprised to learn that actually in-situ data has a raft of inherent values that range from calibration and validation of remote sensing products and Earth system models. We're also thinking about measurements of locations that are actually inaccessible to space-based observing systems. So, for example, within the global oceans, but also areas that are constantly affected by clouds, smoke, or aerosols. The other added value from in-situ data is actually the temporal and spatial distribution and resolution, because together with Earth's observation data, this allows an accurate and more frequent measurement of the Earth system. But also in-situ data, by its very nature, provides a longer time series. And it's also worth noting that, in fact, in-situ or ground-based observations are actually the only legally admissible form of Earth observation data in certain scenarios. And I also mentioned that actually in-situ is now part of realizing GEO's mission and the global priorities that are defined in the GEO post-2025 strategy. I mentioned that the current landscape is actually quite diverse in terms of the data and the different assets that are available. And this is actually necessitating significant investment of resources into curation and archiving. And again, we've heard about a number of projects here this morning. This is just a snapshot of the huge number of activities that are currently underway to actually foster curation and archiving of in-situ data to ensure its long-term availability for reuse. There's a huge amount of data management efforts around standardization, harmonization, and interoperability of in-situ data. Alessandro this morning talked about just one example of those in the context of the ENVRI Hub. But we also need to maximize integration and reuse of in situ data. And this requires new and existing and new observing networks to implement these common data frameworks. But we also need to look for wider implementation of common data management practices, such as adoption of the GEO's data sharing and data management principles, but also the widely accepted fair care and trust principles. So what are our key motivators for the in situ data strategy? I already mentioned that we're thinking about increased coordination of in situ data providers, but we also need to mobilize GEO members and participating organizations, engage with in situ data users, and advocate for in situ open data and knowledge. To achieve this, we actually need to foster a change in the mindset of the global GEO community to ensure in situ data management and data sharing is an integral part of all relevant activities. And we need to support this approach by delivering the tools, policies, and practices that are needed to maximize in situ data sharing and integration. And perfect examples of these are the GEO Knowledge Hub, GREX, and a number of other activities that are underway. So what are the strategic objectives of the in situ data strategy? So we need to think about identifying and monitoring requirements, again, referenced by Alba. But we also need to understand what are the requirements in terms of actually accessing and reusing in situ data. And we also need to understand what are the barriers to making in situ data open and available for reuse. Oh, that's going to jump forward now. We also need to think about coordination at different levels. So again, we're focusing on national and regional in situ data networks across different geographical areas and by domains. And our intention is to try and define and understand this complex landscape, promote sustainability and improvements to observing networks. We need to identify gaps, but we also need to support implementation of the GEO infrastructure that will actively serve as a gateway for in situ data and stimulate adoption of appropriate tools for data management and integration of new data sources. GEO needs to act as an advocate that needs to ensure that it takes a leading role in promoting good data stewardship, encourages the use of flexible and common data licenses, but also illustrates the use of in situ data for increasing environmental knowledge and minimizing and avoiding the loss of in situ data. So I'm going to skip over this slide in the interest of time, but I just want to highlight the fact that in the context of the in situ data landscape, the in situ data strategy identifies 7 key roles for GEO across a number of different activities, which range from advocate through to coordination, but also we need to think about GEO as a facilitator, a custodian, and a redistributor of in situ data. But we also need to recognize the role of GEO in terms of upskilling and capacity building to enhance exploitation of in situ data, and in particular for the next generation of researchers. So we are thinking now more about how do we implement the in situ data strategy. And successful implementation of the GEO in situ data strategy requires a comprehensive and coherent set of actions that need to be undertaken by the GEO community. We need to think about awareness raising, supporting an adoption and implementation of relevant best practices, and ensuring we do provide the tools and the infrastructure necessary to ensure availability and reuse of in situ data. But fundamentally, we need a strong commitment of national and regional and global level initiative to ensure the availability of the resources necessary to support in situ data systems and the associated stewardship of the data and knowledge. So in summary, I think I just wanted to convey 3 key messages about the role of GEO in this context. The in-situ data strategy provides a framework for the open sharing of ground-based observation of our Earth system. And we received a mandate for this at the ministerial summit level in 2019. And we are now delivering on this mandate. And the in-situ data strategy will be presented for approval at the GEO plenary on Thursday. And I see this as a huge achievement for everybody who's been involved with this process, both current and past. The other thing I want to say is that I think the in-situ data strategy provides an approach that is aimed at overcoming specific challenges that have been associated with the acquisition, reuse, and long-term availability of in-situ data, but also supporting the sustainability of associated observing networks. And this includes also identification of critical gaps that will need to be filled for the future. But GEO also has a unique position in terms of its convening power to coordinate the community at the highest level and foster the adoption of the approaches and practices necessary to maximize the access and reuse of in-situ data. And we should capitalize on these opportunities that we have as a GEO community to support the availability and reuse of in-situ data, but also the associated observing networks. Thank you.
Thank you so much, Helen. I don't know how much time we have left for questions. 20 minutes? All right. So I think we can open it up for engagement. All right, I'll start with Bente.
Thank you very much, Bente Liliaby, BLB, and member of the Data and Knowledge Working Group. So thank you to all the speakers for excellent presentations, very inspiring for us working in this committee. I have a question for you, Eleni, concerning the willingness to share the sensor data. You said that you had the authorities with you in some of the examples that were responsible for these networks of sensor data. We know that some of these data are also regarded as very sensitive, and there is some frictions and some reluctance on sharing this data. Can you share some experience on that topic?
Actually, I understand what you say in principle, and I have seen this happening. But with respect to the openness of data in the frame of these projects, and this is something that I forgot to mention earlier, Sirocco plans to put in the GEO Knowledge Hub all data and information. Actually, we have requested access so that we had to develop a strategy on how to upload, but now I think it is the time. We have already collaborated with Alba, and Sirocco is already in GREX. As they have said from Tempo Africa, they plan to upload in the GEO Knowledge Hub, and they plan to submit to become an activity after the completion of the project. EULIA, as I found out, is already at the GEO Knowledge Hub, I mean the data sets. I have explored the projects, and they share a platform, and they share the data sets from these harsh environments. So to tell you the truth, I haven't heard of any difficulty in sharing data in the frame of these projects.
Okay. I think the second hand I noticed before was from.
Yes, thank you again to all the speakers for the very inspiring messages. So I have a comment for Alba, and so for context, this is regarding the eddy covariance measurements that you had mentioned, and I am from ICOS, the Integrated Carbon Observation System. We are an environmental RI, and we have 106 stations measuring exactly eddy covariance measurements, high precision, standardized long-term measurement. So, and we have also been coordinating with regional eddy covariance networks to create the FluxNet measurements, which you mentioned. So I think, granted that the biggest FluxNet release was in 2015, but now I think you'll be happy to know that ICOS, together with the other regional networks, have come up with the FluxNet Shuttle, which is a new tool which will have more continuous release of the flux eddy covariance data sets. And I think it also calls for closer cooperation with GREX and ICOS, and also with the rest of the FluxNet community. I think the time is quite ripe. And at ICOS itself, we are heavily involved in a project called Nubicos, where we are actually working together with the satellite community to define protocols for variables like leaf area index and land surface temperature, and also photosynthetically available radiation, FAPAR. So we are very excited, and we look forward to more discussions with you and the rest of the GEO community.
Thanks a lot for your comments, for your interest. Of course, I am not an expert of flux measurement, so most probably, so you know more. Thanks a lot, and of course, I will come to you later, and and we can exchange.
We should talk.
Yes, thanks a lot.
Thank you. I'll take a hint from you, sir.
Yes, thank you. Mark Denman with the World Resources Institute, based here in Geneva, but fascinating conversations. 2 quick questions, and also congratulations for setting the strategy. I know strategy process is really challenging to do all that. I'm new and learning more about the GEO world and in situ world, but I would love to hear your thoughts on how you're linking and thinking about the strategy to unlocking finance to support this. I know I'm coming from more the water sector, and there's a lot of interest from MDBs and the investors in the finance sector on outcome-based financing. But of course, getting on the ground measurements that could then move from kind of modeling outcomes to the impacts actually having to, in this case, specific watersheds. And I was really excited to see where the strategy is going and merging satellite with in situ. But then thinking of, are you hearing there's an appetite for these funders to also fund the data infrastructure behind all that and to take it to the next level? So one is linking in that to financing. And then the second quick question is related to more to enforce, to Francesca. Love to see the case studies. And I was just curious on how maybe deep into the supply chain or the value chain that your work goes. And we can, I can talk more about the work we're doing, kind of seeing on the ground and the different gaps, but with seeing of, using the enforcement are you going to the tech companies where a lot of either, in this case, maybe critical minerals is in there, they want to have their battery passports, etc. But was curious on where you're drawing the line in terms of engagements in the supply chain of companies trying to report for EUDR or whatever it might be. So thank you.
So maybe I'll reply to your question about, the plan for implementation and how we, aim to secure resources for that. I think the first thing I would say is that we are very much in the initial stages of thinking about what implementation looks like. And part of that implementation plan needs to be developing those partnerships that actually can draw in resources. And that will inevitably mean that we need to identify partnerships, including potentially with the private sector. But also there are a range of organizations and activities, funded activities, that we would hope to leverage in order to actually move forward with the implementation. But again, we still need to do quite a lot of thinking around what that looks like in terms of developing that implementation plan. So I think in short, that's kind of where we are at the moment. I hope that answers your question. Paula is going to add to that, no doubt.
Thank you very much. Thank you, Ellen, for providing the answer. There is, I think, another part of the answer that is important to mention here is that the in-situ data strategy implementation will be joining the implementation plan of the GEO infrastructure. And there are very important aspects to be mentioned here. First of all, GEO, we believe we advocate open data whenever possible, whenever this is the case, whenever it doesn't conflict with other elements such as privacy or targeting wrong information and so forth. So open data is very, very important, and data sovereignty is very, very important. We are a community, as Alessandra was saying, the power of GEO is a community. It's a community of people who work together in trust to advance the data sharing, the management, and the preservation of data for our planet. So we're very interested to learn and to collaborate with potential funders, absolutely, within the GEO infrastructure, by making sure that we protect certain ethical principles that is core for our community. Thank you.
Thank you. Francesca, do you want to answer the second one?
Yes, I can comment very quickly. So I think your question was indeed the most how we're going to enhance as well the data readiness level and how also the different users can use this, right? So for the moment, we are really at the beginning of this framework. To be completely honest, we had some short back on this due to some problems at consortium level, just health-wise. So we have a little bit of delay on this. But the way we started, it was really a survey at community level, really to understand how they see themselves in terms of using data readiness level, what is the approach, if familiar or not. And then the next steps will be really understanding how, for each of the case studies as well, they can connect with this data readiness level framework, because each case study has a different data readiness level due to the different as well environmental context. So maybe some case study would require very high data readiness level to be admissible, for example, to hearing courts and such, and maybe other ones way much shorter. And this, of course, will also be impacting also the uptake as well of this framework as well for other typology of users, notably companies. You definitely mentioned mining. So also this will be, if there will be any kind of reporting based on misconducts or environmental infringements, for example, the data readiness level will be then sort of connected to that type of report. So it's very feasible, the thing, but we're happy to share more when we will advance, of course. Thanks.
Thank you. I'll take your question.
My name is Josh Lyons. I have two questions. First for Francesca, and the second is for all of the panelists. First question, the DRL levels, it sounds fantastic. My question in practice is, who actually is responsible for assigning said levels? This seems like, given the complexity of the data and those levels, it seems like it could be a full-time job, and I'm curious exactly how those levels are assigned. Second question, a little bit more serious. I wanted to specifically ask the panelists if there had been much discussion or ongoing standards being considered for the protection of the scientists, the citizen scientists, the community activists who are actually going to be and continue to be involved in the collection of all of this wonderful in situ data, because in most countries, people face threats of violence in the act of collecting this data. Thousands of people have been killed in the process of collecting in situ data. It is inherently a political issue, an issue of power and authority and control, unfortunately, in many countries. And increasingly now, I've many humanitarian colleagues who are involved in the use of new technologies in humanitarian contexts. The technology is rapidly weaponized against them through misinformation and disinformation. And my fear is that a lot of EU funding in particular is now going into encouraging very vulnerable people and vulnerable communities to be more involved in data sovereignty and collection. And in particular, it's exposing people to hidden threats of violence and in some cases, wrongful imprisonment, because they have apps and data on their phones that are exposing them to levels of risk that they're not aware of. And I'm afraid that I've seen many EU-funded projects that I find extremely problematic for these reasons. And I'd just like to know to what extent is this issue of protection of people part of this discussion? Thank you.
Thank you very much for your question. So I have some notes about the data readiness level that I would like to share indeed, because of course, this framework was, let's say, expanded upon the data readiness level that was already originated from different other disciplines. So then I know that it was started as, originated from information technology to assess health and usability of information systems, then adopted to data science as well. And then the Enforce project with our partner has adopted and expanded it towards this different level of data readiness. So I won't go into details. They are divided into 4. So I think indeed from exploration, where data is unverified, to development, where data becomes more structured, to verification. So here is where the data becomes applications ready, and then applications where really the data is fully mature and used to the highest, let's say, levels, and where spatial, temporal, and juridical, precision is required. So I know that part of this has been developed directly by our partner, who also already develops the so-called MINCA applications, which is now also recognized under the UN as a citizen science repository that gathers already, I think, more than 5,000 imageries and observations already from citizen science, already validated as well by different amount of experts from research to private. So quick answers, no, I don't know, but this has been, let's say, the path, the journey that brought us to the definition of these 4 specificities. I will be happy eventually to put you in contact as well with our point of contact from this. Thanks.
Sorry, Joan, was your hand raised?
I wanted just a quick reaction because we are kind of colleagues in this particular call, no? I'm in this other project that is sister project that is called More for Nature, also citizen science. I just wanted to say that the European Commission is actually forcing us into strict ethical protocols. The ethics is not only a deliverable that you do because it's paperwork. In the case of citizen science, at least in More for Nature, we take that very seriously. Actually, we have a deforestation case in Cambodia where we had to activate these ethical protocols due to exactly the risks involved. There are maybe more risks when you do activism than when you do monitoring, but even when you do monitoring, there are risks involved, and we already have found the case, and we know how to react because we have those protocols. Thank you.
So I'm just going to quickly augment what Sharon said, because I want to emphasize the ethical axis there, because increasingly, as we are thinking about co-design with the community and co-production, part of that thinking is very much based on what is the ethical framework that we need to put around those activities, because we are aware that in certain circumstances there are potential risks. And I think it's not just in the context of EU projects where there's mandated that we, review the ethical aspects, even more broadly. So for example, I actually work for a geological survey in the UK, and we work in a number of countries around the world where this is an issue, where we are co-designing projects with local communities. And part of that includes a risk assessment, not just for our own staff, but also for those people on the ground who are working with our staff. So I think there is an increasing awareness of the need to have that grounding in ethical practices to ensure that we can continue to make the data available, but also ensure that those who are involved on the local level in the process can be, number one, made aware of the potential risks to them, but number two, in some circumstances, provide protection for those people, whether it's physical protection or just anonymizing the data and the source of that data. So there's a whole scale of activities that can be put in place. I hope that answers your question at some level. Right at the back.
Sorry.
Next.
I think we have only less than 2 minutes left, so I'll take that hand and the hand at the back and move to a closing.
Yeah, thanks for all the presentations. I'm Mark Noord of HEP International, participant in the Tembo Africa project. So I wanted to come back to two issues on finance and coverage. Although in Tembo Africa, we propose to do things 10 times cheaper than the conventional method, finance is still a problem. You need simply funding to get in situ data, and we specialize in the hydromet data, and there it's an issue. What we try to do is by the delivery of services that we can, so it's the delivery of services to generate income to make this possible. So that is one thing. And the other, where of course we need the support of GEO, is to talk with the hydromet agencies in the African countries so that they make it publicly available. That is the other. We always will have the constraint. Our best paying clients are hydropower companies, and they really want to have their data confidential, but it facilitates to make other data available. So indeed, it is an issue that needs to be solved, this financial issue, but there are ways that we are trying to do it. And with the coverage, the GREX exercise was very interesting for us, especially because the problems we are facing in Africa is more of not so much of the quality of the data itself, although that in some cases can be improved, but it is a geographical coverage of having more hydromet stations in Africa, because that is where it is totally lacking and falling short at this point. So that is something that also in a GEO context we want to keep promoting. So thank you very much. Yeah.
So my short answer to that would be that we definitely need to have a conversation, because one of the things that we have been seeking to do is to leverage other activities in other communities, because we don't want to keep reinventing the wheel. We want to work together and develop a collaborative community that is not just in one lane, but actually integrates and interacts with other activities. We're all facing reducing resources for many of these activities. And if by combining our resources and focusing on some common challenges, that's definitely got to be a win for everybody. So we should definitely have a conversation.
I think we are out of time. Maybe
There's
like,
one
let's just take
come on.
that.
Thank you. I've been raising my hand since the start. So sorry, I'm just going to bring in a third community to the conversation, and it's the Citizen Science Global Partnership, which is a network that aims to advance citizen science for sustainable development. And we're trying to use citizen science data globally to leverage it for environmental monitoring, but also Earth observations and all the other approaches. And we've been working with the national statistical offices to integrate data from citizen science into official statistics. And we have experience in that process as well. We've been active in the past in GEO, but then the resources issue came about again. And we haven't been so active, but we would love to be part of these conversations again and to work with you all on citizen science and how we could leverage this alongside Earth observations data to address environmental issues. Thank you.
Thank you. And Paula just wants to.
Yes, just before we close, I would like to remind you that the next session will start at 2 o'clock. It's going to be about national geo-knowledge hubs. So a lot of the discussion we are having here somehow strengthen national partnerships and so forth can be brought also to the next session, because we know that by the adoption at the plenary of the in situ data strategy, members will be owning that strategy and will have to implement them in their countries. And so we follow up the discussion with the national geo-knowledge hubs. Please join us. And back to you. Thank you, Lee.
Thank you. Let's give a round of applause to all the speakers again. I will close off this session and thank you for bearing with us with the time. And if you are attending the plenary on Thursday, please support us for the in situ strategy. Thank you.
Congratulations.
我们或者去录一下，然后对，是那个，下都是宏观的，对，视频，天脏了，那也行，对他，我想起来，他那特地说应该是这个意思，对。Good afternoon, everyone, and welcome to the second session of Open Data, Open Knowledge Workshop 2026. Hope you had a good lunch and you are re-energized for the new session that we are addressing. I am inviting Mr. Kofi Nyarko to join us, representing Ghana. Thank you very much. There is a chair here, and I will be moving on. We are truly excited on this session because we will be sharing with you the experience from multiple parties from South Africa, from Ghana, from China, as well new experiments related to a self-standing GeoKnowledge hub. But this discussion that we are going to go through today is the result of very engaging discussion we had in ODOC, Open Data, Open Knowledge Workshop in 2023, where countries that we have aligned here today were discussing how about establishing a national GeoKnowledge hub. And so this discussion, they do bring fruits, they do bring results, because we act as a community leveraging the open data, open knowledge, open tools that we are building to enhance this sharing of very important knowledge. So without further ado, I would like to introduce our next speaker, Felipe Carlos. Felipe Carlos is a GEO Secretariat member and has a background in computer science, and with a master's degree on reproducibility of Earth observation application. And the GeoKnowledge Hub is all about reproducibility, reusing what is already existing, adapting to different countries to face the similar problems countries are facing, but just readapting without reinventing the wheel. So, Felipe, the floor is yours. Thank you.
Okay, thank you so much, Paula, and hello, everyone. Good afternoon. So thank you so much for joining us in this National GeoKnowledge Hub session. So for this first presentation of this session, I will be talking about the National GeoKnowledge Hubs, how we are implementing them, and from where we started, and what are also the current status. So before I go and talk about the National GeoKnowledge Hub itself, I would like to use a few minutes to just talk about the GeoKnowledge Hub itself. So as Paula mentioned, the GeoKnowledge Hub is a digital library created for the Geo community, by the Geo community, to preserve, disseminate, and support the reuse of Earth observation applications. So in the Geo community, we have a lot of Geo work program activities, and they produce a lot of data, code, paper, and all these materials, all this knowledge they are producing, we keep preserved in the GeoKnowledge Hub. And we have been developing and evolving the GeoKnowledge Hub since 2021, and all the features we have implemented so far, all the changes we have made, all of them are based on the community engagement. So when we started the platform, we had, let's say, a base version, and based with interactions and feedback, we evolve the platform. And of course, GeoKnowledge Hub is all about keep things open, keep all this knowledge and content produced by the Geo community centralized. Of course, it's important to keep things preserved. When we are sharing content in the GeoKnowledge Hub, the content is curated in terms of metadata, in terms of organization of the materials. So this way we ensure what we are sharing there is well organized and others can reuse. And this is important because one of the activities we have in the GeoKnowledge Hub is also the engagement. So once we have the content available in the digital library, our goal is also the Geo community to reuse that content. So we have these two pillars, let's say. One pillar is the community sharing the knowledge there, and another pillar is the community reusing that. And for this, we have a lot of these engagement activities. And of course, when we are talking about the GeoKnowledge Hub as the central place for the Geo community, we are thinking in a global way. So we have applications from multiple countries, for example, addressing different issues, and using different methodologies, techniques, and tools, and so on. And of course, it's important to have all these available. This is what we have been doing in the last years. But when we go to the, let's say, when we need to act, it's important also to consider the information in the local. So let's say a member of the Geo community wants to reuse something available in the GeoKnowledge Hub. For example, a software or a tool available there. All this reusage process needs to be localized, contextualized in the context of the of where this will be reused. So we see this pattern when we go to this reuse of the content. We have the global GeoKnowledge Hub sharing a lot of things, and when we contextualize, we link that content with issues, with the communities in, for example, countries, with activities running in countries. So when we started to see this pattern, and after a lot of discussions with the Geo community, we realized the importance of having a national GeoKnowledge Hub. So we have the global GeoKnowledge Hub sharing all the content from the community, and the national GeoKnowledge Hub contextualizing that content, linking with national issues, for example, or activities running in a specific country. So this is why we started the National GeoKnowledge Hub. And of course, apart from this contextualization and to facilitate the reuse and discovery of the content associated to issues in a country, of course, when we are talking about national GeoKnowledge Hubs, we are talking about sovereignty as well, because the way we develop this solution, countries can run by themselves the tool. So they have the infrastructure will be running their own premises, for example. Of course, they have the possibility to customize that, so they can change even starting with the look and feel and go to the content itself, how they are indexing and storing the content. And of course, this is feature rich because the national GeoKnowledge Hubs, they are connected with the global GeoKnowledge Hub. So we have all these preservation-friendly features we have in the GeoKnowledge Hub, and these possibilities to customize and keep the content stored locally as well. And of course, as we were starting a new software in the GeoKnowledge Hub ecosystem, we define as one of the principles to keep things easy to use. So it's easy to use, to deploy, for example, to maintain, and of course, allow countries to customize so they have their own national GeoKnowledge Hubs. And the solution for that was a light tool. So basically a tool that allow countries to easy deploy this, the tool itself, and start the customization and indexing content. So by indexing the content, they have in one central place the things, or for example, the materials, the activities from the country centralized in that page. So it's the same idea of the GeoKnowledge Hub, but with a different scope. And I think it's important to highlight this. We started, as Paula mentioned, this activity as part of discussions we had in ODOC 2023, and South Africa was the first country to adopt the National Geology Hub, and together with the team, developed the National Geology Hub. So this was a co-creation process, was a very interesting process, and I will be sharing a few details now. So as we were creating a tool from the community and for the community, all this process we followed was always using this consensus-based approach. So for all new features, the changes we were doing, the evolvement, new features, removal of features, we were always consulting, in this case, in the initial version, South Africa. So they were providing for us like feedback in how to approach few things, how to what to change, what to remove. And of course, with more countries joining, we keep this approach, but consider more feedback and more views as well in the process. So this is just to summarize the way we were developing. So countries were sharing content, and while they were sharing and organizing the content to ingest in the National GeoKnowledge Hub, we were running this cycle of develop new things, enhance what is available, and sometimes remove features. So always keep this iterating. And of course, to make this possible and to allow all countries to benefit from what other countries were doing, we selected a component-based way. So this means, for example, if South Africa suggests an implementation of a new feature, this feature will be implemented and available not only for South Africa, but for all other countries deploying and using the National GeoKnowledge Hub. So this way we keep everything always open, accessible for all countries. And this is just to show in a very high level way how the National GeoKnowledge Hub looks like when a country is deploying it. So in a National GeoKnowledge Hub, we have connections to local content, and local in this case means physically where the metadata and the files are available. So available in local servers, for example. So we have information about the training of in that country, events in that country, institutions, people, and all this. And for the remote content, we have all the things we already have available in the GeoKnowledge Hub. This means knowledge packages, knowledge resources, and all content preserved there. And this is just to highlight a few things and how countries are able to customize and use the National GeoKnowledge Hub. So this is one example of Ghana Knowledge Hub. This is one of the initiatives we are running now. You see it's possible to customize, for example, from their main page. They are able to change, for example, colors. They're able to, in this case of South Africa, change the way people see like the main page of the country. So in this case of South Africa, they have this customized version with the images and all the colors and things they selected. And for the content, as we were working with countries, our goal was always to integrate as much content as possible in the National GeoKnowledge Hub. So, of course, open content and also commercial content. So this is, in a nutshell, what we have developed with the National GeoKnowledge Hubs. Our goal is to, of course, integrate more countries and keep this process of always follow this consensus, so we implement features that will benefit all colleagues. So this is just to mention the next steps. In terms of software, one of the things we are already working to evolve, and this will be presented in this session as well, is a way to deploy not only this light version of the National GeoKnowledge Hub, but the complete GeoKnowledge Hub itself for countries who want to have the GeoKnowledge Hub running in different ways. Of course, with new countries, enhance the customization and the community around these National GeoKnowledge Hubs to keep the software evolving. So with this, I finish my presentation. Thank you so much. If you want to support and you already use the GeoKnowledge Hub, I will, this is the QR code to provide feedback in all the things we have in the platform. So please feel free to provide comments. Thank you so much.
Thank you very much, Felipe. I think the word co-design, co-development, engagement with the community is the key here. Global, think global, act local is the way the Geo Knowledge Hub and the Geo Infrastructure is acting to organize the variety of Earth observation, data, knowledge, applications, existing efforts all over in a easy, discoverable, accessible, and reusable way. And we're very, very pleased to welcome as our next speaker, Dr. Bolelang Sibola, working at the Council for Scientific and Industrial Research in South Africa. And I would also like to mention here that we are missing two other representatives of the South Africa Knowledge Hub, Lulu Makapela and Kwanele Ngongoma, who have been actively working on establishing the South Africa Geo Knowledge Hub. We are extremely proud to welcome you, Dr. Sibola, for you to share your experience with us. Thank you very much.
Okay, is this on? Good afternoon, everyone. Thank you, Paula. And I just want to acknowledge my colleagues at home, Lulu and Kwanele, who were not able to travel this time, but they have done the heavy lifting behind the development of the South African Geo Knowledge Hub, as Paula has mentioned. I will therefore represent them and also the views from the stakeholder community, as I am the co-chair of the Data and Open Data, Open Knowledge working group in South Africa within the SAGO portfolio. So, okay, let's see if we can move this. So I just want to pick up from where Felipe left off, and really what I will be showcasing is how when you co-develop and co-create, not in speech only, but by actions, you can really lead to developing great things with the communities that you work with, and therefore then that translates to ownership of what you have created. It's not only just then Felipe telling people this is great software, but they own it, they feel they have worked on it, and therefore we can today show a perspective from our side and how it has helped us within the South African context. So initially, I'll just like to talk about the SA Knowledge Hub in relation to the SA Geo community. So the Knowledge Hub creates a dedicated space for us, obviously, to store and manage information, whether it's data, products, or even some of the services created by local South Africans, but also creating an integrated community also, because we get to see what everyone in the country is working on. So the landscape is usually that you will have a lot of projects that are run by different groups, and to avoid repetition and to create knowledge sharing amongst the different groups, you need a space where you can all be able to see this information, learn from each other, and even communicate. So this is what the SA Knowledge Hub has created for the South African community. In terms of the priorities or the data that we show on the portal that we have worked on with Felipe and the team, we looked at the South African environmental problems in general and tried to align this with the national priorities and policies as communicated by the higher levels of representation for South Africa within GEO. And this relates to health challenges, whether it's climate, energy, urbanization, weather hazards, and there's a lot of them, but we grouped them specifically to relate to the problems that we face and how we address them. So the implementation process was very interesting because it was not just a co-creation or co-development space where it was the developers working together, but they were also bringing the community into the discussions as well. So we approached the South African GEO community to tell them about the Knowledge Hub and how they can provide open tools and share information, case studies, publications, or any other services that they have created. And after sharing this, the community would then engage with us, submit all the work that they have done through a form or a portal that we had created for them. The team then organized all the information to look through if there are any duplicates or any other organizations that we know of that have not committed yet, and really just try to engage them into sharing information themselves. Once we were happy with the information that was created, then a review was done between the main Geo Knowledge Hub team and the local team to see how to then normalize this information, standardize it, and provide it in a standardized manner where it can be searchable and discoverable. Then once this has been done and consensus has been reached, then the information then gets published into the Geo Knowledge Hub. So what you see is in front of you is the data once it has been properly curated. Before this, it's a bit of a mess because we're getting notes from this institution, from that institution, and trying to harmonize, see where the groupings work and where they don't work. And I must say the groupings still provide a bit of a headache because sometimes you'll find that one project will fit amongst several different groups. So you also have to think about those things as well. But once this is done, then the information is provided as you can see on the screen. So this is all the background work that I'm talking about, but eventually the tool had to come into action. And this is what the South African new Knowledge Hub looks like at the moment. The customization that Philippe mentioned, that each country can decide on the look and feel and what it wants to look like. I was in several meetings where there were discussions about what the banner must look like and what the customization will look like. Those may seem like trivial things to people who do software development or in general, but if you give people the opportunity to choose things to the point where they even choose colors, it means a lot to them because they then feel like they have contributed. And as you can see, or if you may know, this was aligned with the National Earth Observation and Space Secretariat in South Africa. So the heading then creates a seamless look between the what already exists and how the Knowledge Hub then fits into the space of the data products that are available within NEOS as a portfolio. So then when you go into the Knowledge Hub, you will then get to see the different groupings of the products and services that are available. In this particular case, we're showing the products that we have for agriculture and food security. And the writing is a bit small, but they are grouped into software packages and also knowledge products. And that's where you also get your publications versus the tools, if I can put it in simpler terms like that. Okay, I think I skipped one exercise. Then the most important thing that happens then is that you have to re-engage the community again after asking them to contribute their data. You have to tell them what you have done and where you have placed their data. So through our capacity building activities and events that we hold as SAGO, we re-engaged the community again. We showed them the Knowledge Hub, and I think we even asked Paula to give a presentation in one of our sessions through video. And this is where the buy-in happens, because first you have a software tool that's standing on its own. Then now you have more people seeing, oh, this organization has provided data and this is what it looks like. And they also then start adding more. So I think there has been a steady increase in the number of tools and services that we have been seeing being contributed to the Knowledge Hub. But I must emphasize again, sovereignty is a main issue, and people will not just want you to take their data. They want to know that it will adhere to specific policies and that they still own and keep the raw data themselves. So what we provide is a reference to the different portals, and therefore creating a community and not a replacement of what is done in the community on its own. So I think these are the main SAGO people that are involved and led specifically by Lulu Makapela and Kwanele on the development side. And in terms of stakeholders, we have roped in the main geospatial agencies in South Africa, including the various research councils and environmental organizations. Leo comes from one of our Earth observation networks as well. They do a lot of data curation as well, SAON, and they are represented in the stakeholders as well as the CSIR, SANSA, and again, regionally AfriGeo. We also cross-pollinate, if I can put it in that form. So yes, these are the products that we have. And recently we have launched the marketplace on the Knowledge Hub. The marketplace, I think Philippe touched on it a little bit, where This is for the proprietary services that you have, because not everything will be open. Some things will come at a cost, but even if there's a cost, people still need to talk about what is available and how to share that information. And thus the marketplace creates an opportunity for this. So I think I've touched on the challenges that exist. As Felipe mentioned, we were the first organization to start with this. So we could either be stoned and thrown out of the room or embraced. There has been a lot of embracing that has happened. It hasn't been a smooth process because people wanted to know why the Geo Knowledge Hub and not this or that. But we keep engaging. We keep telling people that we all one creating an ecosystem of products and not a replacement of one with the other, but bringing more people together. And also the sustainability of the product comes from the ownership of the countries. If Felipe has to maintain everything on his own, I promise you nothing will go as we want it to be. But if we have created this ecosystem of people that work together, then you will get to sustainability. So thank you very much, and I hope I have represented the partners well in this exercise, because it wasn't a one-man or a one-group journey. It was a cohesive exercise by the South African GEO community. So thank you.
Thank you very much, Dr. Sibola. We will welcome questions after all speakers have gone through their presentations. So keep your questions and write them down so to engage with all of us at the end. I would like to take few keywords that are building throughout our journey on National Knowledge Hubs. We heard co-create, co-design, community contribution. So it's all about co-create, co-design, community contribution, ecosystem of products, data sovereignty, and sustainability. So it is a wonderful journey that we are walking together. And what South Africa experienced throughout the establishment of the first National Knowledge Hub has been adopted by our wonderful friends from Ghana. And Amos, who is here, has been an advocate for the establishment of the Ghana National Knowledge Hub. And very smoothly, with a community of experts in Ghana, we started this, again, process of creation of the National Knowledge Hub for Ghana. So I'm very, very happy to welcome here Kofi Nyarko from University of Cape Coast in Ghana, who will be telling us the story of the Ghana National Knowledge Hub. Thank you and welcome.
Thank you very much. As rightly said, Ghana had it somehow easy because South Africa had to go through all the trouble, and we had to perfect it. So, and it's but before going through, we asked ourselves, why do we need open data and also open knowledge? We realized there are a lot of products in this world that are quite open, and things that are needed are quite closed. So we realized that open knowledge is key, and having open data is also quite important, because in the application of geospatial sciences, realize that Earth observation is critical in all decision making in various fields, in terms of climate resilience, sustainable development planning, and because most politicians, excuse me to say, are not knowledgeable in the use of Earth observation data, because the processing is tedious, but we have to make the products quite open for them for form of decision, and also in environmental monitoring. Well, there are some challenges in this open data and open knowledge. In Ghana, for instance, despite the growing need or the use of Earth observation data or coming out with various forms of processes, we realize that most of the data have remained fragmented. They are not continuous. So if it's fragmented, then you need to fill in the gap, which makes it quite very difficult. And also we find out that, yes, we call ourselves a middle income country, but we don't have the resources to continuously use Earth observation data. So we need to discover where we can get the resources from. And there are a lot of duplication of efforts, which sometimes you can't blame us. You also blame the development partners because they don't have knowledge about what is happening elsewhere. So we need to look at this effort.
It's on.
Yeah.
Okay.
Okay.
Is this the wait?
Okay. Yeah.
Yes.
So in this regards, what was our vision for the Ghana Knowledge Hub? One, the vision was to establish an integrated national observation knowledge ecosystem that supports sustainable development, scientific innovation, evidence-based governance in Ghana. And it's also hinges on some strategic pillars of open data. If you want evidence-based governance, you need open data and also open knowledge to have open science. And the design and developing a very good decision support system within the country and build capacity of Ghanaians from the kindergarten level to the retirement level, because most of our politicians are about 60. Yeah? So we need to also build their capacity to understand the use of Earth observation data. Well, in building the Ghana Knowledge Hub, we went through a series of activities, and one critical thing was the kind of impetus that was given to us by Amos. He encouraged us as a team. Then through that, we had a whole lot of engagement with the GEO Knowledge Hub team at the Secretariat. We're having weekly meetings every Thursday for an hour. Yeah. Well, so, and it was quite interesting because at least, so then also we had to identify stakeholders and establish the Ghana Space Science Institute coordinated all these activities. In developing too, we had to, in trying to bring other stakeholders on board, or what would say onboarding, we also had a 2-day capacity building training, and the purpose of the training was to build the technical capacity of those involved and also to promote long-term sustainability, to let them know that the data they are providing is not for the Knowledge Hub, but it's for them, but they only pitch their data onto the Knowledge Hub. The 2-day capacity building was organized by Paula in the group, the GEO Secretariat, and it was quite interesting. And they provided us with a gamut of knowledge, including that of the overview of the Knowledge Hub, the platform and its functionalities, and open knowledge principles, and how to publish your data. So out of that, we came out with the Ghana Knowledge Hub. See the nice Ghana flag. And the Ghana Knowledge Hub, the priority areas is based on the priorities of the government, on the National Development Authority in Ghana. So in this case, we looked at One Health on health-related issues, agriculture, water resources, land, and sustainability. So we know that there are quite a lot of benefit from the knowledge hub, from governance, agriculture, climate and environment, also research and innovation and capacity. The government, in terms of research, the government is coming out with a 1 million coding program. It says that within the end of the term of the government, at least 1 million people should be able to code. So with innovation, coding with Python and Earth observation will be one important key element. These are the stakeholders, at least, that there are a lot of them. We have the University of Energy and Natural Resources and the Ghana Space Science Institute, University of Cape Coast, SESGIS, Kwame Nkrumah University of Technology. The Ghana Statistical Service hosts a chunk of most of the spatial data in Ghana. Okay. So, what's the way forward? Yes, we want to strengthen the coordination unit of the Ghana GEO and also promote open data policies and stronger partnership with GEO, Digital Earth Africa, NASA, ESRI, and others, and also sustain continuous knowledge contribution. Just with that, I'll say thank you.
Thank you very much, Mr. Dr. Nyarko.
Kofi?
Kofi. Okay, thank you very much, Kofi. It has been and it will continue to be a pleasure to work with you and the entire Ghana team. In fact, what you have presented is the best practice is how to establish a national knowledge hub. And this is exciting because we hope, and it will be decided by each of the national GEO, whether or not establishing a national knowledge hub. It is a decision from the country itself. And it is marvelous to see how with a community building, with empowering and organizing existing efforts that are many in the countries, things get clearer. The data becomes more accessible, knowledge becomes more accessible and more accessible by everybody. And this is really the objective, one of the objectives of the national knowledge hubs. So to continue our journey that brings us in another part of the world, we are now moving to the experience from China and from Dr. Li Kuo-ching, a long-standing member for GEO. And Dr. Li has been working also at the European Space Agency, was very active in the former GEOS platform, and now leading this effort for China. And we are excited to hear from you, Dr. Li. Thank you very much.
I'm not sure it's the right version. No, it's not the right version. Excuse me, it's not not the right version. Oh, okay. I can use it. I think it's Maya have sent the new version of it. Okay, I think we have no time to change it. I can use this version. Okay. Sorry. I'm watching it from China. It's my colleague. It's Dr. Ma Yue. It's worked with me to prepare for the presentation. Here is we'd like to share our experience on how to build the national knowledge hub in China. Let's begin a story. We should know some background of what China have done. In China, the knowledge hub is not the things is from the zero. It is it's a continued work from the China GEOS is a data sharing the network. The China data sharing the network is a facility created by the China GEO Secretariat, leading by the Ministry of Science and Technology. This work in this platform is the resource, the hub in China to collect and harvest all the efforts and the resource to be the different ministry, different university, different the space agencies in China about their data and the other resource is contributing, have already contributing to GEO. As well as the China scientist related to the GEO is work plans program. The China GEO's resource now is increased from the very beginning time. It's a few of the resources now have extended. It's very much now in this system. They have about more than 27 sub centers in different ministries and university and space companies, and about more than 120 satellites have been involved inside. Most of them is more than 100 is the Chinese several satellites, and the data sites and the data collection have reached to is more than 2,000. There is some stage. In the first stage is the trail. In the trail stage, in the very beginning, is before it's 2017. In this stage, it's just focus on the data sharing, just to collect some the views of the data resource and just show the capacity of how to apply the GEOS the principle, data sharing principle working here. It's in the very beginning time, and it's also the it's the big efforts in China to start the data sharing work inside China. It's a quite new things. And in the second the stage, it is the interested operation, and in this stage, all the resources have increased very fast, and more and more as the resources have been merged inside. We have delivered a lot of the service applications, and there's more kind of resource have been merged inside. And now is we are entering the new age, just with the steps of GEO. So it's a new age from data sharing to the knowledge sharing. So we built the China GEOS infrastructure. We use the framework of GEO Knowledge Hub, the GEO Knowledge Hub, and to rebuild the Chinese facility. And in this stage, the new is the system, the official the new system provide a lot of the service. It's very interesting. It's a data fund data. It's only one function, and we have the function solution. The function solution just like the package, the knowledge package, and the found topic. The topic is related to the GEOs. The GEOs is the software benefit is the catalog, and also the friend partner is the human network. The scientists, the teams, and also the institute. So all this is the different layers of the knowledge have related to that. And we also have as you to collect the knowledge from is different of the international is a programmers have initiated is by our center. For example, we have a CPUS is worked with Chinese National Administration of Space, and we taking charge of the data sharing from China to other government. And we also have the Global Air. Global Air is a new the AI resilience is the efforts worked with UNESCO with the since the decade. The idea is to use the easy to use and the AI tools to work for the global south to use the benefit of the observation and AI. And also the CDR is the main channels for the global partners to access the Chinese the commercial satellite resource during their disaster events. We have the response to more than 50 events around the world. Yeah, it's the list that we have around and worked with the UN, the families. And in this stage, the new is a Chinese the platform. We also name is a China GEO Knowledge Hub. The mission is we have also the share the missions, the visions with the GEO Knowledge Hub, GEO Knowledge Hub together, and we also use the technical standard to make an interconnection with GEO Knowledge Hub, and to link that the two the locals and the global system. And the last one is called the resource of that is now in the first stage we have selected is about 896 the knowledge resource from China and contributed to the GEO Knowledge Hub and present it to the China Knowledge Hub portals. Is some example of that some the resource, the data resource is about the GeoArc. We know it's a GeoArc. There's the annual report from China. It's not only report but also with the data sites. The very high resolution data sites, and so we give the story every year and to present it as the main resource, and also we give the global cover is 5 meters the data the resource of a Jilin-1 satellite. It's a 5 meters is a resolution with the 20 bands. It covered is 100 is countries, and we have present that with also the some applications, the guidelines how to use this data. so for the last is our work also have been shared is with our international partners, and we have also is a ground is a ground is with the SNAP of the world and also the GEO. For the last sentence, because it's not the right is a presentation, so I'd like to give the last sentence about is what's the problem and what's the next step. Now is we just the very beginning of us is to connect with the global knowledge hub. So we just share we just shared is a few of the resources here, and all the resources we according to the standard and we standard of the GEO, and we make it to the control of the curations and the policies, and also the link with the knowledge is the package. So it's in the next step is we will select and rebuild. It's more as a resource from China, from our Chinese partners and stakeholders, and also is shared directly to the GEOs is the knowledge harbors, and which is the can benefits to the GEOs is communities and also the GEO work plan programs. Okay, thank you very much.
Thank you very much, Lee. Excellent intervention and very, very rich information. We apologize if the presentation was not the right format, but I think the audience got absolutely the wealth of contribution that China GEO is bringing to the GEO infrastructure, to the global GEO knowledge hub, to the national plan for a national GEO knowledge hub. I would like to say something, is that in the first 20 years of GEO, we have been advocating, we are still doing, for data sharing, for data management principles. We've been advocating, started to advocate for knowledge sharing, and now we are in the post-2025 strategy, Earth Intelligence for All. And here what I hope you can see, that we are doing great steps together towards this Earth Intelligence for All, because Earth Intelligence needs data, needs knowledge, needs data knowledge that are properly documented, that are owned by the countries, and that where you can act upon. So it is very tangible for, hope, all of us, that we are walking in that direction in a very concrete way by having national GEOs working and establishing national GEOs together with the global GEO infrastructure. And this is a major direction that we are walking, and we will be continuing to walk together. And our last speaker, we are super excited because Terra 2 is a GEO associate, and Pedro is our next speaker, is a co-founder of Terra 2, GEO associate, is an SME, small medium enterprise, and Terra 2 has been generously supporting the GEO Knowledge Hub team, because at the moment you see the four of us, Kalamkas, who is up there, Felipe, you know all Felipe. We have Letvin somewhere in the youth session, and I am the coordinator. But we also have another amazing young person, Abdul Fuseini from Ghana, who has ended his master's degree in geospatial engineering in the University of Stuttgart. He couldn't join us here. And Abdul has been generously supported by Terra 2 to contribute on the development of the self-deployable GEO Knowledge Hub. So I am very, very honored to thank you first, Pedro, and to give you the floor to tell us the story. Thank you.
Thank you very much, Paula. Thank you very much to all for these great presentations. I loved how we started with Philippi, reproducible science, the knowledge hub. Our country started from scratch, applying it, and then another, and then even China trying to, there's a long history of already a system implemented. It's more difficult sometimes because you have to replace something than starting from zero. So it's quite impressive. But a point that we need to be sure in our minds that this is the first step. So we need to have data sharing, knowledge hubs, but then this is the first step because what we want is a reproducible open science. Our target here is really not only data sharing that I can access the data and discover data, but I need that we have reproducibility, that someone somewhere finds my paper, finds my algorithm, and is able to run it all over again, be it in the same area, be it in a different workflow, be it a different infrastructure. And this is something that we've been working for. It's quite key because we've been working for the past years with the OGC, with the European Space Agency, with the European Commission, and we put these angles of reproducible open science in 3 major points. That the knowledge hub is a starting block. It's the starting block that we need to have. It is visibility in terms of finding what are the knowledge and the workflows and applications that can be reused. Thinking about portability, that an algorithm should not be stuck or locked into a specific platform, clouds or countries, and transparency in terms of the methods, in terms of the algorithm, in terms of the configurations, in terms of all the hidden parameters that you need to run some types of experiment. And the knowledge hub for us is a starting block of this. And the national knowledge hub is something that we need. For this to appear, we need to have several elements appearing in different countries and collaborating, and with this co-design appears, might advance something. So we have these 3 principles, and what we are following is strategies that we want for reproducible knowledge ecosystems. So reusability in terms of we put the communities, we put the different national knowledge hubs in terms of reusing workflows, or even to put changes, adaptability for their own national context, and at the same time a way to preserve reusable research assets. And portability is an important point here because yes, we are doing something here, but we can't say, oh, but in fact, it only runs on this or in that platform or in that country. We need to avoid this dependency. And so we've been working a lot the past years with the OGC, with the European Space Agency to say, okay, what are the building blocks that you need to avoid this dependency so that you are then able to create platforms and infrastructure that are sovereign and we are able to reproduce in different elements. All of this needs also the knowledge hub in terms of transparency. So all these flows in terms of how to document the application, how to document the code that is being used to produce this pretty graph in this paper. They need to be accessible. They need to be available, even in a context that, yes, we want to promote collaborative science, but also in a way to reproduce and to validate what's being said. So for us, the National Knowledge Hubs is really the first step toward this distributed and sovereign open science infrastructure. It's an important step that we need to have countries, and these 3 examples are very good, and I've known other countries that want to start their own national hub, and we will be growing this small by small, but we'll be growing this knowledge that we can possess. And this is something that the knowledge hub fits an interest of the countries in the sense of immediately they can now say that they are preserving and managing their own Earth observation knowledge. They can, as we've seen these 3 examples, contextualize it to their national priorities and build local operational capacity. It's not something that they are just saying, oh, I'm using a software that some people in Geneva are developing, in Brazil, but also adapted to their own places and to their own team in a sovereign and sustainable infrastructure, because this needs to be also needs to have a notion of or how the national hub is being sustained by the national government within the line of the national policies. And this is the national side, but for us is that, okay, we keep those players connected to the global geo ecosystems. They are not doing yet another portal, yet another standard. We are sharing standards and interoperability. We are doing open science practice, and we are collaborative knowledge sharing. And I'll speed up because I still have Abdul that needs to have a video. So from the territory point of view, we've seen, we discussed this when we discussed this like 2 years ago, and then again when we were in Rome last year. We've seen that there was necessary support from our knowledge. We also giving, it's not only traineeships to Abdul, but also the team is trying to guide them in this, using in our experience and the projects we have to see how they can really improve the reproducible deployment, the configuration, all of this, that then will be easier. It was already easier from South Africa to Ghana, but my idea is that it will be almost automatically that each new country that appears will be able to do this. So for the technical part, I think I will there's a video of Abdul. I just click here and he will.
Yes. Hello, everyone. I am Abdul Husseini, and I'm an intern at the GEO Knowledge Hub. In this part of my presentation, I would focus on the reusable deployment solution that is meant for the GEO community and beyond. The solution is based on Kubernetes, and it is to make it reusable and scalable for the GEO community members who want to deploy their own knowledge hubs. The solution is actively supported by TerraDuo, a GEO associate member, and it is to make it straightforward and simple, easy for the GEO community members to deploy their own knowledge hubs without needing to go through manually setting up everything from scratch. Kubernetes is basically an open source system for automating deployment, scaling, and managing containerized applications. What it means is that it groups containers that make up an application and put it into logical units. That is for your easy management and discovery. With Helm chart, it is like a recipe for your Kubernetes application. And that makes your application, it packages your application into a reusable form, and you can deploy the application in different environments. You can also track changes with this Helm chart, or even share your knowledge hub or your application with internal or external users, which can be done for internal purposes. You can use Hubble or Artifactory, or for public purposes, you can use Docker Hub or Artifact Registry. This is basically a glance of the architecture that we are using. And to mention, this architecture is based on the Invenio RDM framework. And it is to make knowledge sharing, as you know, much more easy and open for the community. So all these components are open source tools and platforms that are being used or integrated to make up this platform. At the top, basically, you see we have the application layer, and at the bottom, we have also the back-end services layer. And the web, in this case, actually is a pathway or gateway through which users can access the application, and which consists of salary workers and salary beads as well as Flower. At the back-end services is Postgres for the database or for the data sets that you're producing, especially your metadata, for instance, or Redis, which is now used to cache your sessions. As you may recall, the GEO Knowledge Hub is built on top of the Invenio RDM framework, and that means that we at the GEO Knowledge Hub are not reinventing the wheel. We are just building our products on top of the Invenio framework. Here is the simple workflow that illustrates how the community can use the Helm chart or the GEO Knowledge Hub as a Helm chart to deploy their own knowledge hubs. So at first, an admin would have to pull the application and modify the values file. So in this case, modifying this simply means, for example, the image or the host name and the config file for the Invenio. And with just one Helm install at the workstation, Helm deploys everything into the Kubernetes cluster. So in the cluster, the application components are all deployed together with their dependencies, the bundled ones, and each of these with their persistence storages. Now, Nginx controller serves as a platform or a mechanism that redirects the incoming request to the appropriate nodes within the Kubernetes cluster. When users try to access the application, their requests are being redirected by Nginx ingress controller to the respective node. For example, if they are trying to access the web, then Nginx controller would redirect this request to the appropriate node that contains the web. Or if they try to access the API, then Nginx controller will say, go to the node that contains the API and pull it for the users. Now, this is very important, especially for the GEO community. For example, in this process, in your deployment process, if any part fails and you have to start all over again to fix this part, it becomes very cumbersome and it can be very time consuming. But Kubernetes now makes it much more easier. So you have nothing to worry about when it comes to, okay, one of my servers is failed. Kubernetes would basically replace it. It will create a new pod or a new node and replace. These are basically the prerequisites for you to be able to deploy this application locally on your machine. All these technologies listed here are open source technologies and they are based on open standard. So you need Docker, you need Minikube, and you need key control, ingress controller, as well as the Helm chart. So in conclusion, I would like to say, if you are considering having a new platform for your country or for your organization due to certain policy changes or due to your use preferences, and you're looking for a scalable way of doing that, which is also reliable and faster, then you may like to consider this solution that is developed together with TerraDuo for your use case. The documentation for the GEO Knowledge Hub and this deployment process is put together and can be accessed through the following link. On this note, I say thank you very much for your attention and I wish you a successful symposium. Do have a great time.
Okay, thank you very much. Yes, okay, it was a bit technical, but I think it was important for him also to show and to express that the roadmap to really be able to deploy and to manage national knowledge hubs. It's approaching.
Thank you very much. Is in fact with emotion that I was listening to this video because Abdul is an integral part of the team, has been working from remote from Germany, and we value very much his contribution. We value very much TerraDuo contribution, and I think you must also be excited to learn that this self-deployable GEO Knowledge Hub is on the way. This can really bring a tremendous scalability of the National GEO Knowledge Hub, as you have heard from all the examples from the countries. So with pleasure, we open the floor for questions to our speakers. Don't be shy. We have 10 minutes if you compromise your coffee and knowledge. We have one question there from Thomas Orestes Amos. We will start with that.
Yeah, thank you. Thank you for these presentations. I'm wondering how we manage the global knowledge hub with all these national hubs. Are they linked? Can the national hubs feed into the global one so that that is growing, and maybe also other nations can take stock of what is there already?
Felipe?
Yes, thank you so much. This is a very interesting question. And during the development of the national node, we followed the same philosophy we use in the main GeoKnowledge Hub. So all the things we are developing is always REST API first. So then we have well-defined and standardized REST API. And then we start the development of the front end itself. So in the National Knowledge Hub, and thanks to these APIs, we have the possibility to import content available in the GeoKnowledge Hub, and in the Global Knowledge Hub do the same thing. And this is because in both sites, we are using DataCite metadata schema as the standard. So in both databases, we keep the same structure, so then it's easy to interchange the content. So they are connecting, and when we connect a new, for example, we developed South Africa first, then we implemented Ghana. They will be all integrated thanks to these API connections. And one of the things we are doing now, and this is already, part of this is already available in our online documentation, is the documentation for all these REST APIs. So all these things we are developing, we are creating proper open API standards. So it's all documented to show how these connections are working, how maybe you can create our own interface based on this content as well. So stop here. Thank you.
Yes, Thomas asked exactly what I was about to ask. A bit more in particular about the user stories. I'm thinking that if Ghana develops a really nice user story on crop type modeling, for example, it would be nice for someone in Bulgaria using natural language to find this Ghana story and identify themselves in, okay, perhaps I can also do this, just as a added thing on what Thomas asked.
Orestes, thank you very much. You are spoiling the presentation we will give at the plenary. So indeed, it's these recipes, because at the end, if we look at the problems that our world is facing, are always the same: drought, flood, biodiversity loss, pollution. And so one country having that knowledge can be inspiring another country by readapting that open knowledge as existing solution readapted to the country, and change few things in situ data, but we are adopting the in situ data strategy, so no problem. We will move forward on that, and we move concretely on this Earth Intelligence for All from open data, open knowledge. Thank you. Amos.
I did ask for the floor. Benjamina BLB, a member of the Data Knowledge Working Group. I have a question, follow-up question for China. You all had different, starting points, some new, some learned. And for some reason, I think maybe the Chinese situation is the most complicated, as Pedro was saying. Because you already have a system, you already had China GEOS actually. And my question, and China is a very big country with very many different institutions. Could you say something about how you think about onboarding more institutions to your system? Will, for instance, the GeoKnowledge or the local knowledge hub be more attractive to some organizations, or will it be the existing or the older China GEOS, for instance? Have you made some reflections around that? Thank you.
Okay, thank you for your question. This question is especially for China. Yes, actually, the options you gave to me, my answer is we cannot select anyone. We keep both. Why? Just because it's for GEO, this interface is we apply the technical trends from GEO, the knowledge hub, and we select all the materials, all the resource, all these things need to be integrated with the knowledge. The knowledge hub, all the resource should be application oriented. So it's everything, even the data and the paper and the human resource and also the related the project. All the things should be linked together. It's with the geo-related project. So we select the resource can match this requirement is not too much. It's not, so we select a few of them. And for the others is the task of such platform is try to collect this more and more data, and to provide is much more is the service to the local users, the communities. So we use is a different the umbrella to do that things. For the geo, we use is the third version, the Knowledge Hub. In this from or the new is the system, and inside China for the much wider is the user. We keep the national Earth observation data center. It's a government level and the nation level data center. In China, only 20. In different the high energy, the materials, the gene. The gene is a micro, is a medicine. For these things, for the National Artificial Data Center, they collect this more data, and now is the data sites have reached is 10,000. More than 10,000, and the data amount have reached to is more than 20 gigabytes. It's very, very huge. However, it's the things that can match the requirement from geo is only few. And also, we need to consider about is the data policy, the sovereignty, is anything. So it's a very strict control. So they link together. They link them together. We need a server for the local community, and we also server for the geo community. So we need to keep touch, keep both of them. Okay.
Thank you very much. Very, very interesting question to be continued probably over coffee. Also, Amos.
Okay. Yes. In fact, as I sat here, I felt a bit emotional when I listened to all the three, with the third one, the China case, just informing us about how, at a higher level, all the different possibilities. That even gives example for Copernicus and all the other programs that we have, which means when we are able to solve, let me call it, the China Geo algorithm, we will already have solved the global issue. And there is one example which I would like the Chinese colleagues to look at it, because already there's a lot of work between China and Africa on that. It is called the China Africa Satellite Application Center, and they are deploying a lot of information to specific African countries using different algorithm methods. And I think it could be an example at another level to be able to see how they could implement that. I strongly feel that this CAXA Center could even think about a possibility of getting a secondment person in China who could work with the team to make sure that this is done. Thank you.
Thank you so much. I think we are done with interventions because we have 5 minutes to grab a cup of coffee before the next session starts. And then we have 2 subsequent sessions always in the room. So we invite you to do a big round of applause to our speakers. To believe in what we're doing. And the next session, join us here in 5 minutes, because it will be about governance, principles and rules for the geo infrastructure. And this is extremely important. So thank you very much for your engaged audience and participation. And thank you to everyone in the panel. It was a marvelous session. Thank you very much.
Okay. Welcome, everybody. As you can tell, I'm not Paula De Salvo. I am Bente Liljaby from Norway, BLB, and I'm also a member of the Data and Knowledge Working Group. I'm going to be moderating this session. It will be my pleasure. We will, in the interest of time, I think we go straight to the point. And start with Margarita Di Leo from JRC, the Joint Research Center for the European Commission. And we are going to talk about the self-assessment tool, self-assessment of being compliant with data management principles. Margarita.
Okay, thank you. So I'm going to present the user-centric self-assessment tool for cloud platforms. Okay, imagine you want to book a flight from point A to point B. You use a comparative website, right? So you don't go on the air flight companies to check every single flight. So what we understood about the users using a cloud platform is the difficulty for them to pair their needs with the offer that is there. And they need to go on each and every cloud platform in order to understand what are the services offered and to understand if these services are what they need in their development life cycle. What do we need? What do we mean by cloud platform in the first place? So we created a sort of a taxonomy for a cloud platform, and we include data providers, geo-processing clouds, brokers, catalogs, but also thematic hubs, research platforms, data cubes, and also virtual infrastructure. And we mapped over 150 existing platforms. We have analyzed the whole ecosystem available to developers, the whole ecosystem of cloud platform, from the perspective of a developer of a policy relevant use case. And we have analyzed their user experience. The developers along their life cycle, they need to integrate more services offered by different types of platforms for their own use case, and they face some problems that are, for example, discoverability. They cannot find data, services, usability, because they want services integrated seamlessly. And also, there are problems of transparency related to licensing, sustainability, and performance that are poorly communicated. We have co-designed with the users during a workshop, also in a past GEO event, a set of principles to understand what is the problem. Okay, so the principles that you can navigate from this QR code are essentially related to interoperability, discoverability, customization, community, sustainability, access, documentation, customer support, price transparency, and performance. And this we have translated into a actionable self-assessment framework, which is currently a prototype. It's temporarily hosted on a free platform. You can access from this QR code and using a username and password provided. This is not a permanent host, but it's fully functional, okay? So this framework has been designed around the three design principles that are technology agnostic. So it focuses on outcomes and not on the specific implementation. It is evidence-based, so each criterion specifies what evidence demonstrated. And it's constructive, so it supports improvement and not rankings. And it recognized that platforms exist at 4 levels of maturity, which goes to emerging, to developing, to established, to leading. So we basically applied this self-assessment framework to our first use case, which is the GEO infrastructure. And I would like to hand over to Felipe this part, because we developed this together with Felipe, with Kalamkas, and with Paula.
Yes, thank you so much, Margherita. So when we run this assessment, and this is just to provide a little bit of context, we were evaluating this new version of the geoinfrastructure we are developing. So this new version will be introduced in the next days. And as we were developing and we were keen to know what we need to evolve and what we need to change in this new version, we run this self-assessment in this tool we are developing now. So this included the GeoKnowledge Hub, which is the main and the core system in this new version of the geoinfrastructure. This also included the DAB, because now in this new version, the GeoKnowledge Hub is connecting and searching content using the DAB, and for the yellow pages and the management of the providers as well. So this is one of the things we are still working, for example, to normalize what are the knowledge providers and data providers using the content from yellow pages, for example. So just to provide this overview in what we evaluated.
Okay, so here you can see the assessment results. So the tool gives an overview by means of a spider graph, and in blue there are the levels that are already achieved, and in pale blue there are the levels that are achievable. So basically the platform is already working towards improving. And this self-assessment can also be used as to be run as a, so this is a baseline, and then for example next year could be self-assessed again to see what has improved. And so these are the strengths that emerged from the evaluation, and these are related to discoverability, to community, to interoperability, and also to access. And as you can see, there is evidence about the claims that that are made. And also the tool provides feedback on improvement opportunities. So I think it was also useful for the infrastructure to understand what users may desire, and what improvement could be made in order to make it more accessible and more user-friendly. So in conclusion, this tool is useful to provide short-term actions that are of high impact for the improvement of a platform. The framework supports iterative improvements, so it can be run several times in the course of the year. and can be used to monitor the development of a platform, and it is replicable across other platforms. So we welcome any other use cases that are willing to try it. And thank you.
Thank you very much, Margarita. Again, we will have questions. Please note your questions for the discussion part. We will see if we can save some time to ask question and discuss. Again, we have a shift of both the order of the agenda and the person. You are not seeing Lionel Menard here. You are seeing Gregory Giuliani. He is from University of Geneva, but he is going to present the new support for the GEO data management principles on the data management plan Opidor platform. Gregory, the floor is yours.
Yeah, thank you very much, Bente. And as said, I'm speaking on behalf of Lionel, and I will present some of the work we've been doing for the past few months, also with some of our students here at the University of Geneva, on implementing the geodata management principle on top of this DMP Opidor platform, so that will support end users in managing and developing data management plans that are in line with the GEO principles. Is it working? Yes, sorry for that. So it's going to be the main announcement of the day for us. It's the official release of this tool. So it's called the GEO Machine Actionable Data Management Plan. So really, it's using the Opidor platform, which is a French-based platform that allows any users or contributors to the GEO work program to create a data management plan based on the GEO data management principles, to deploy the work and the template done on the open platform DMP Opidor, to enable also the collaborative writing and creation and revision of any DMP related to any specific project. One of the key functionality also it allows to have a fine-grained access and right management, so you can define editors, contributors, and so on and so forth. It's completely free and open, so it's still as usual, I would say, in the spirit of GEO. The only thing is that is required is to authentify within the platform, so you have to register first. There is an open API, so that it's machine actionable, and you will know that probably we have some discussions already with Felipe and colleagues within the data working group to enable communication between that platform and the GEO Knowledge Hub, and it's going to be a single access point. So it's available on that URL, and this is a work mostly done by Min Paris, so Lionel Menard and his team, by the INIST team that developed the Opidor platform, and we contributed at the University of Geneva through one of our certificates of geomatics student, Braulio Galicia, who did most of the work. And this work has been supported by the Institut Carnot in Min Paris Tech. So they financially supported that work, and you can also see that work as a contribution from the EuroGeo. And this is based, I forgot to mention that, it's based on the former Excel sheet that Lionel developed in the past within the eShip project. So now it's, let's say, the more digital version of this Excel sheet. So the main concept, as you can see on the screen, so it's using the Research Data Alliance template, so this 6 level for the DMP. So it's a fixed schema, and what we have done basically is to map all the GEO DMPs according to this 6 level. So you will see that on the platform you have access to pop-ups that gives you directly the connection with all the DMPs. So we've done, and Braulio did
a lot of work on this mapping with the GeoDMP. It has been done within the certificate of geomatics, and also the report done by Braulio is freely available on the University of Geneva Open Archive. And it's really an intuitive tool with an easy interface, and I will show you just and guide you through the interface. So as I was mentioning before, the first thing you have to do once you connect to the platform is to create an account to authenticate yourself. So it's not a big deal. You can choose. The only trick is that because it's a French tool, your organization is likely not being registered within that platform. So you can choose this new organization level so that you can then be recognized on the platform. So choose this new organization. That's the only trick. Once connected, then you can create and start creating your plan. You see, it's quite intuitive. You can even import if you have already created also a past DMP. You can import the DMP in the system, or the easiest way, create a new one. Once you create that, obviously, it will ask you to create according to a certain specification. You can choose the language. Obviously, we'll use English, and then it will guide you through the different steps of the creation. As you can see, it's quite intuitive. You can obviously put a title to explain the plane, what is the abstract, what is the outcome. You can also, and you will see it's connected already to Cordis. So if you're part of a European funded project, so you can search for your specific funded project, and then it will also bring some of the information directly from Cordis, so the official title, the official abstract related to that project. And then you will be you can fill the different steps according to the DMP. You can invite also people, add also your objects. So either your services you are documenting, the data you're generating out of it, and so on and so forth. This is the level also where you can select the official, let's say, schema related to GEO. So you see it's quite easy. And here you have this 6-level document. So it's not the traditional GeoDMP, but for each of these questions that you will have to fill in, so you see that the 6 level, then you have this small star, and if you click on the star, then it opens a pop-up where you see the description and the mapping to the GeoDMP. So you see for each of these 6 levels and each of these bullet points that you have to complete, then you have a clear description related to the GeoDMP. And it's also connected, and you see you have hyperlinks that goes back to the Geo website where you have all this definition. Then you can also invite people to contribute. So this is here where you can define your user contributing and defining their profile basically. So it's quite traditional. And once it's done, then basically you can define their access level, and then you can share it also with others, and then hopefully also download your data management plan. So it need to be used, so you can see a PDF export of your data management plan. This is an example done by Lionel. So it's, I would say, a way that is way more easier to handle data management plan than we use in the past. And as I was mentioning, and this is going to be probably the last slide, so there is also an API. So this allows this machine actionable communication through the platforms, and now we have ongoing discussions in connecting this tool, this GeoDMP Opidor tool, together with the Geo Knowledge Hub, so that there will be a clear communication between the two elements and the two components. So it remains you now to play with it, to enjoy it, and also to contribute to the community so that we can in the future improve this data management tool. And we hope you will appreciate that effort that we've done through also this EuroGeo activity. And thank you for your attention.
Thank you very much and congratulations. I feel that we reached a milestone because we have discussed this so many times and so many presentations, and the community has already contributed to developing this. So this is a co-design effort, and we hope that we will continue along that line. I know that you, Gregory, you have to go in not too long. So I will allow a couple of questions for you if we have that in the audience. Do you want to ask Gregory a question? You have to ask now.
I will.
Yeah, Helen, I give you the floor. Thank you. It's on.
So, Gregory, I have a question for you. So we've been thinking a lot in the context of a project that we're working on funded by the European Environment Agency called GeoIdea. And we've been trying to assess using a small number of projects, and I'm going to talk about it in a minute, what are the issues with compliance with completing data management plans? So my question to you is, how do we incentivize people to make full use of data management plans so they move from this administrative burden to an asset for the research process? Do you have any thoughts about how we might shift the needle on that?
Thank you, Alan. That's a very good question, and that's a tricky question because we're still, thinking about it and being a researcher also, even in Switzerland, when you apply for any research fund, you have to comply and write a data management plan, and that's like metadata. We don't like to write this kind of boring stuff. So I think that's going to be also something we need to collectively co-create this incentive all together to show the benefit of having this data management plan to the entire community and to explain that carefully and in detail. Because I think that's part of the documentation process also for our scientific knowledge. And that's extremely important. But obviously, we are lacking this incentive and we are lacking time in completing that. So we hope that this tool can at least ease a little bit the process and speed up also the process in writing and co-creating, because you can have this collaboration with all the colleagues within DMP. So it could facilitate somehow the writing of these DMPs.
Thank you. Yeah, Karamkas.
Thank you, Giuliani. I just want, it's not a question, I just wanted to share with you feedback that I tried myself already DMP Opidor platform. And thank you for Lionel. He helped me a lot in testing the tool. And I know that I'm related to the GeoKnowledge Hub activities, but I tried it for my research for dissertation, for the doctoral research. And I think this is very great tool for students. And I think this tool can help them to build their research proposal, especially for doctoral students. This is just to share feedback. Thank you.
Thank you. Excellent. Recorded. So thank you, Gregory.
John has been waiting.
Oh, sorry, John, I didn't see you. You have to laugh.
I'm so quiet. No, I just wanted to say that we need to make people understand that the good thing about the data management plan is actually executing the data management plan. So the plan is really boring stuff, but the benefits of having the execution of the plan is you end up with a catalog, you end up with your data accessible, etc., etc., and we can understand that as a practical thing. So I believe the Commission is wrong in actually forcing everybody into a plan that is never developed into anything that is concrete. So you, at the end of the project, you are never obliged to present a catalog, for instance. That is what I would expect it. Because, you have a plan to actually execute it, not for the sake of having a plan. Then, of course, nobody likes the plan because, why? So, well, that's my contribution.
Okay, thank you. Paula?
Yes, so just one idea, short-term funded projects, 3 years. Yes, they need a plan, but they don't need to build a new catalog. They don't need to build a new portal. They don't need, they can rely on what is already existing. And so if we integrate the Opidor within the GEO Knowledge Hub, it's done. They just have to comply to the GEO Knowledge Hub and it will be naturally implemented. That's a way forward. Yeah.
Yes. Yes. So thank you very much for both your questions and your comments. I refuse to call data management boring. I think metadata and caring for the data is the opposite. Hence, I'm in this committee. Now we have, at the core of GEO, we have the data sharing principles and the data management principles. That's the foundation of GEO. And with the new strategy, Earth Intelligence for All, very shortly, we can say that without any Earth observations, there will be no Earth intelligence. And without proper caring for the data, we will not arrive at intelligence either. Now you heard how we can manage the data, some tools for data management, both on the infrastructure level and on the data level itself. But it doesn't happen by itself, does it? We require some knowledge. Those who are working with the data in detail need to talk to them, those who are actually using modeling and transforming it to Earth intelligence. So there's a thematic competence as well that is needed. How do we fix that transfer of knowledge? This is what Marie-Françoise Vadreau will say a few words about now. The dialogue series, I hope you have heard about it. We are connecting experts with worldwide community to shape GEO action, and it's Marie-Françoise Vadreau, currently One Single Earth entrepreneur, and also working, of course, in the GEO Data and Knowledge Working Group. Marie-Françoise, the floor is yours.
So in the last years, we have built some dialogue series to connect experts with the worldwide community and to shape GEO action. And this is the topic of the presentation. And by the way, I'm happy to talk after Gregory because we have made several dialogues on the data management tool. How does this work? Isn't it like that?
Yeah, if you press it, it should go.
Okay. So when we talk about Earth intelligence for all, the challenge is to move from observation, from data, to information, then knowledge, then decision, and then action. But in fact, this is not only a digital issue. The digital issue is big. I agree with that. And to move from one level to the other level, we need APIs and interfaces everywhere. But in between all these different levels, we also need humans. And the purpose of the dialogues is also to give the humans their place again. And I'm very happy that Alessandro has emphasized, Alessandro Turco this morning, the importance of individual and connections because all this is not magic. So we know that there is too much fragmentation between the data, fragmentation between the technologies, the systems, the knowledge, the policies, and the communities. And if we do not solve this fragmentation, we can have a data overload. And what we want to do is synthesize and connect all that. And you can connect at the different levels, but you can have also to connect through the different levels. And this is where you need expertise and you need to connect the people. So we also have a lot of diversity of the data. But among each of these bubbles, we have seen this morning for the in situ that we also have a lot of diversity with different types of data. We have diversity among the communities. We have diversity among the technologies, the AI technologies, the cloud, the modeling, around the different policies. We are talking here at global level, so we have a lot of different policies, and we have a lot of disconnected communities. And we try here to address global challenges. When we talk about Earth intelligence, we talk about climate change impact, we talk about global loss of biodiversity. And so we need to connect at geographical level, at domains level, and at technical level. And we have seen this morning that these connections have to go through individuals. So the dialogue series is a new concept we have designed with Bent to try to address that. And it's an innovative online format where we connect diversity of experts. So we try to build an agenda, but with the Earth observation community, because all these dialogues are completely open to all. We communicate very much through LinkedIn and through the GEO networks. The purpose is to promote the data sharing and data management principles and the open knowledge as a foundation. We want to strengthen the collaboration across the data providers, the scientists, and all the different profiles we have in the community, so including policymakers and users from expert level to beginners. We want to capture user needs and real world experience, and this is very important because it's a bilateral. When we talk about dialogue, you have two directions. The direction where you give the information and the direction where you listen to the community to understand where are the challenges and what they want to address. This is the only way you can help, is understanding what people want to do and where they are blocked. So what makes it different? It's again interactive and community-driven online events. We try to make very short talks to set the panel, to be inspirational for the discussion, to make people understand what is the topic of the dialogue. So we put a lot of stress on the speakers because we ask them to introduce their expertise and their solutions in less than 7 minutes. And then we keep time. The idea is to keep time for an open exchange and reflection and collaboration. This also builds the engagement because when you know the other people, when you know the challenge, when you know what you are doing, you create a real connection. It's not only listening to one. So the format is 90 minutes. We usually have between 3 to 7 speakers. As said, it's sometimes more, but we try to avoid. It's very short talks, and we try to have a clear storyline across the presentations, because if you go fast and just present presentations which look completely disconnected, the audience is lost. So we try to create a storyline to explain each of the talks in the bigger framework. And sometimes we make some live polls to engage more with the community. And we share a lot of resources via the chat. And this works really fine because the audience also share a lot of resources via the chat. The key benefits are cross-disciplinary and I would say cross-background knowledge exchange, a better understanding of the user needs, a stronger GEO community and partnership. We build a lot of the community beyond these great events like this one. We need more momentum during the year. And all of these dialogues are recorded, and we build like that new granule of knowledge which are shared on the GEO Knowledge Hub openly. So the idea here is to share a global expertise for local action. So again, this global to local, we have seen into the global knowledge hub and the national knowledge hub. And the dialogues are just a vehicle to share the knowledge and to connect people. So I say that we build on the GEO data sharing principle. We have moved to open knowledge, and we extrapolate these principles of sharing as openly as possible without charge and restriction as fast as possible, because this is the challenge for universities to catch up this knowledge that improves and develops very fast with a quick mean, which is distributing through these dialogues on the web, and we try to share with a minimum delay. So considering the past dialogues, the first ones were about the data sharing and the data management principles, the data lifecycle. We had also here a dialogue on the data management self-assessment tool, the very first developments. And you have here a QR code that links to the data sharing principle recording. But if you look for the dialogues about the GEO data management principles, you will find several dialogues going into detail about the principles and their implementation by some experts. Then we did some dialogues in 2023 about the different strategies to approach open knowledge. And this has been very good also to help the GEO community understand and think about how can these different strategies apply to GEO? How can we implement that? How can they be used for GEO? And I think it has been mentioned this morning, for instance, with morning, the afternoon, I don't know, it's continuous for me. The open reproducible research and the open science, all these have been mentioned several times during the day. And it's also here, you have a QR code to the resources which are shared on the Knowledge Hub. And then we had some dialogues to go from principles to implementation about the data sharing and the data management principles and about the open data licensing, because you know that we also have a subgroup about licensing and they edited the new guidelines and we have something on that. Out of these dialogues, we have extracted some success stories, which are also shared on the Knowledge Hub, on the self-assessment tool, but also on data sharing and on the data preservation, which is something which is a bit at risk currently in several countries. And you have here all the QR codes. In 2026, what did we do? We did a series about, again, all these different topics, and I'm going fast because I am monitoring here the time. And what is interesting is that we are getting a lot of traction. Last year, we had more than 697 registrants, 340 attendees, meaning more than 70 attendees per dialogue. These are the ones who attended more than 15 minutes. But in fact, what we observe is that most of the people stay until the very end, even if sometimes we go a little bit over the deadline of the end. And it's the last slide, so it's okay, time up. So what we see is that we really engage globally, which is another challenge we can have here. And if we want to serve GEO, is that we have more people, a little bit more people from Europe and the Americas, a lot from Latin America, but we also have quite a lot of people from Africa and from Asia, which is really great, and we are happy about it because it's a real challenge. So this is it. Thank you.
Thank you. Let us give Marie-Françoise an applaud with the hands on the head. I see that people are, it's late in the evening, so they have to do it. Let's wake up. Yes, we have 2 more to go. And it's, yeah, one other session, yeah, that's right. But in this session, we are now, so Marie-Françoise was talking about transfer of knowledge, making these data work for you through the principles, and best practices is another way of transforming that, being inspired by what others have done. And Kalamkas Yesim Kanoa currently from the GEO Secretariat, and also, as we heard, a PhD student, almost finished. Kalamkas, the floor is yours.
Thank you so much, Bente, and thank you for joining us today. I'm Kalamkas, I'm from Kazakhstan, but I'm representing here the GEO Knowledge Hub. This is the tool of the GEO, and I would like to talk about best practices for the GEO Knowledge Hub providers. So as The GEO Knowledge Hub is the tool of the GEO. It is the central cloud-based digital library that designed to preserve, disseminate, and support the reuse of Earth observation applications developed by the GEO community. So I would like to just quickly go through the concept of the GEO Knowledge Hub that we use. It's a knowledge package. So knowledge packages is an application sharing unit that contains knowledge resources that used to create that application. So you can see that by having the concept of a knowledge package, we centralize all the resources with metadata, the files itself and some auxiliary resources. And the resources can be very diverse, starting from the imageries, in-situ data, scripts. I think this is now more popular, right? So workflows, results, publications, and so on. And as the presentations on the best practices, I would like to say that these practices, of course, based on the geodata sharing data management principles. And the first point that I would like to highlight is clear documentation, as the clear documentation serves here as guidance for the users of your application. What is the application about, how to use it, how to access the different resources, and so on. So think of it as a user manual. And what we suggest in the GEO Knowledge Hub that your user can be both technical and non-technical person. So keeping all the documentation throughout the package and its resources, so both of them can clearly understand your application and how to use it. And next point is descriptive metadata. And here metadata serves as a roadmap of your application. And the more so we would like to have the metadata rich. So you can, if you attended the first session on the Institute, there was a presentation of Alessandro Turco on the integration of the GEO Knowledge Hub and Envy Hub next. So through the rich metadata, you will get the visibility of your application when integrated with different services. Next one is effortless access. So when you provide the resources, either it's a data set or it's some materials, any related resources, it's important to give basically direct access. So we would like to break here the barriers and complications that users may have to access your data and script or any other resources. Publish all work components. Of course, it's important to have all the resources complete, but I would like to highlight here the scientific part of it, some journal papers, so the users can understand the scientific base of your application, of your work, and can go through the methodology. And as a part of it, sharing the training resources. This is also important, as your user may be the youth, the young, the students, and they can learn how to use the application, and so they can level up their knowledge and skills. And basically, if this can be the user can be also, of course, senior student from the other major. So this is basically helps to build capacity around the application. The licensing aspect, this is also crucial, as it define the terms under which the user can use your application. So it basically protects your intellectual rights and to help the users to know how to use your data, your software, under which license they can share, modify, and so on. The next one I would like to highlight is user stories. This point, the user stories kind of add personal touch to the application, and by showcasing how the others who are using your application can inspire others, and also it helps to in terms of scalability of your application. Interact with the community. This is also interesting part. In the Geo Knowledge Hub, we have different features to facilitate this part. For instance, a user may ask you as a knowledge provider, a training. Could you please provide me a training or help to use your application? Or the users can ask any question or leave the feedback on the organization of the resources and so on. And apart from that, in the Geo Knowledge Hub, we're organizing webinars together with the knowledge providers to share with the community their work and how the application can be used. Another point that I would like to touch on the sustainability. Thinking long term, it's very important, and I think this is what we discuss many times. And in the Geo Knowledge Hub, we facilitate this point by two features. One is assigning digital object identifiers, and the second one is hosting capability of the Geo Knowledge Hub. So each resources can have up to 20 giga of memory. So we would like to preserve the work that has been done. This is valuable, and so the efforts cannot, the efforts actually should not be done twice or more than that. And of course, staying always up to date. In the Geo Knowledge Hub, we developed the automated tool, link checker, and it is already available online. This tool designed to support knowledge providers to see where in the package or in the resources we have broken links. So this is very, I think, in my point of view, this is very valuable tool for the Geo Knowledge Hub itself and for the provider, so they can identify directly which link is not accessible. As I mentioned earlier, all these recommendations designed to help knowledge providers to build rich in terms of metadata, description, and so on, knowledge packages and resources. And all these recommendations are based on the geodata sharing data management principles and geodata licensing guidance. You can find all of them in the Geo Knowledge Hub. And another tool that is available just recently this week, it's available from this week, self-assessment dashboard. This tool is designed for potential knowledge providers. So it helps to evaluate your content. So for instance, if you're not sure that the content that you have fit for package or for resource, so going through this dashboard, you can first assess what metadata you need, what metadata, like, the required one, the recommended, we have also optional metadata, and how you can organize all this content, if it fits for resource, if it fits for package. So this self-assessment dashboard helps knowledge providers, potential knowledge providers, to evaluate their content. And I don't know if you were before checking the presentation of Felipe. He was sharing the QR code. We would like to hear the experience of a knowledge provider and user, of course. And would like you to scan the QR code and leave us feedback as we want to improve and serve the GEO community. Thank you so much.
Thank you very much, Kalamkas. And as you said, everything is on the Geo Knowledge Hub, so you can consult it there. Now moving on to the next speaker in this session, we are going to be introspective. And before I give you the floor, we have a very long title on your talk, Helen. You know Helen Glaves.
It's not really mine.
It's not really yours, okay. She represents, in this case, the European Plate Observing System. And of course, she's the in situ data subgroup co-chair. And we will hear more from you also the next coming days, Helen. And she's a very passionate advocate for in situ data. So the floor is yours, Helen.
Thank you for the introduction, Bente. So yes, it's me again. But I'm actually making this presentation on behalf of Julia Kaufape from Evenflow, who is not able to come to Geneva this week. So we have been working in a project called GEO Idea, and this project is funded by the European Environment Agency to actually undertake a whole raft of different activities. I'm actually going to focus in on one activity today around data management plans. So I need you to cast your mind back to the presentation that was given to Gregory a little while ago, because we originally planned that these two would be in tandem, but Greg has had to leave. I just quickly want to give some context for the work. So I'm going to say a few words about the GEO Idea project and the work that we have been doing thanks to the European Environment Agency. And Jean-Philippe is here in the room. So if you have any questions about the project, you can ask him directly. I wasn't going to resist the opportunity to put you on the spot, Jean-Philippe. So the project is around providing expertise on open sharing and management of in situ Earth observation and geospatial data. And the focus is very much on data relevant to the European context, but also global climate adaptation policies and initiatives. But one of the most relevant parts of the work that we're doing here is actually the support that it brings to the coordination with the Group on Earth observations, and in particular, a number of the activities that we've been undertaking in the context of GEO have been supported by this action. In fact, the dialogue series has also been supported in part by this action as well. So we have a number of tasks that are very much focused on GEO's data sharing and data management practices and initiatives. But we're also supporting the implementation and promotion of the regional EuroGeo and the related activities there. So we have different activities both at the global and the regional scale in the context of this project. But one of the critical things that we're doing, and the thing that I'm going to talk more about today, is we're thinking about standard processes to facilitate the reuse of in situ data, and in particular, how these relate to the GEO priorities. Oh, apparently I'm not going to talk about it. Oh, there we go. So what I'm actually going to talk about today is how the role that data management plans play in facilitating and promoting sharing of in situ data. And this is why actually the talk that Greg gave a little while ago is actually very relevant to what I'm going to say. So we've had an activity that is basically focused on assessing the availability and usability of in situ data and explore the potential for developing an automated process for this assessment as it relates to data management plans. So basically, the approach that we've adopted is that there were a cohort of 29 Horizon Europe projects that were actually pre-selected that are generating in situ data. And the idea was that we would assess the level of availability of the in situ data and the role that the data management plan has played in making this in situ data not only accessible, but reusable, because the two things are actually quite different. So there has been a two-strand approach to this. The first has actually been to look at where the in situ data is actually available that's been generated by these projects, and indeed if it is even available somewhere. And this has actually been quite a labor-intensive human review, looking at the data management plan and undertaking a desk study. The amount of work this involves meant that we also have developed, or Julia developed, an AI workflow for this activity. And this AI methodology was very much around trying to identify digitally where and how we could access in situ data from these 29 projects. I will say that there was a human quality check involved in the AI process to make sure that it was actually doing what we thought it was doing. But we've also had to validate the results that have come from the AI aspect of this work. But actually, to augment this desk study and this AI work, we've also conducted a number of interviews with the individual projects that have been reviewed to actually assess the level of success of the evaluation of the DMPs we've done. And this has actually been quite revealing in terms of what we found out from a dialogue with the project leaders in comparison to what we were able to learn from the data management plan and the methodology for AI discovery of the data in different repositories. This doesn't want to work today. So there was a small set of variables were used to identify the level of documentation of the data. So there was metadata standards that it used, data formats, types of license that are available, the license type, so whether the data was actually open, restricted open, or actually it wasn't clear what sort of license the data had. On a very fundamental level, it was about identifying whether the data had a DOI, whether it had a landing page, but also we had a look at what was the nature of the repository that was used. Was it a large-scale repository such as Zenodo, or was it a domain-level repository? So what did we learn? So we discovered that of the projects that were assessed, virtually all of them, the data was available. So it had a DOI and it had a landing page. But actually the level of reusability was a little bit more patchy. 62% of the data was considered to be usable in terms of the format and the license that was available and the level of accessibility. And then 37% was partially reusable. And this meant that some of the critical information necessary for reuse was actually missing. The next part of this process was to actually evaluate the data management plan that was provided as part of the documentation at the initiation of the project. And this was equally revealing. We discovered that for 9 of the projects, and that was actually 64%, their original data management plan was fully aligned with the availability of the data in terms of metadata, the repository, etc., and also the licensing and availability. A further 4, there was a partial match in that there was some compliance with their original data management plan, but not all. And in a very small number of cases, in fact 1, the data management plan bore no resemblance to what happened at the end of the project at all. So what did we learn from this process? So we learned, number 1, human validation adds irreplaceable value in the process as it stands. The direct desk research and direct project engagement actually revealed a lot of information that the AI screening missed. We also discovered that in a number of cases, despite what was put in the original data management plan, the final data was actually in Zenodo. And in fact, most projects default to Zenodo in the absence of any clearer guidance. And it was also very obvious that we need a shift in culture. We need to think about how people think about data management planning, compliance with data management, the data management plans themselves, and how do we embed data management plans into the data workflow and active stewardship throughout the project life cycle, so we stop it being an administrative process and make it part of the research process and valid outputs. I'm going to skim over this very, very small slide. If you have interest, there are a number of high-level insights around compliance tools. So we've already mentioned data management tools, but also there's repositories, the value of using a domain repository over what is euphemistically called a data bucket in some spheres, but also the value of data repositories being involved right at the start of a project. So if there is a long-term plan that starts at the outset of the project, and there is a direct interaction with the repository that the researcher plans to use at the end of the project. So very quickly, because I've had the time's up slide already from the colleague here. So what are we going to do next? So we want to continue to build relationship with the interviewees from each of the projects, but we also want to leverage community expertise. So from people like Greg, who are working on data management tools, but there is a whole community of practice around machine actionable data management plans that we need to draw on. This methodology will be scaled up to increase robustness and include a number of additional projects. We need to think about how do we improve the automation of the assessment process. And finally, we need to understand how do we integrate the findings of this work into policy and practice? How do we make as much use of this information as possible to inform policymakers and those funding agencies who are responsible for allocating resources to future research? And I think that was Julia's last slide.
Yes.
It is.
Thank you. Thank you very much, Helen. We have 5 minutes for questions before the break. I just wanted to add, Helen, that you're talking about, of course, the scientific community, but in GEO, we also have the administration and other operational services, and it's equally important for them. I just wanted to say that. Now, the floor is yours, and Jean-Philippe, I give you the floor.
My question is for Helen. So thanks a lot for your work. I mean, you mentioned that a lot of the project that you looked at put their data on Zenodo, which is not the optimal format. And I was wondering whether at the moment we have tools or suggestions or something that would help them find suitable repositories, or is it something that the working group should look at, or do we need community inputs here?
So I think there's actually a couple of answers here. There are a number of tools, repository finder tools out there that are available. So in fact, if you Google repository finder tool, there are a number of that come up, including the Re3 data catalog of domain level repositories. There is also something called the Core Trust Seal repository certification process. And they actually have a list of certified repositories and identify which domain each of those repositories serves. But that is only a snapshot. We need to also understand what happens to orphan data that doesn't have an obvious home. And in fact, the GEO Knowledge Hub is one possible home. If we can't find a suitable home for a particular data set, particularly those that Paula mentioned, short-term 3-year projects, rather than somebody keep it on their computer and it gets lost with time, the GEO Knowledge Hub is a potential option. But in a way, this is a tiering of, from best to, last resort, and the best should be the domain level and last resort should be the Zenodo, and I think the GEO Knowledge Hub comes in there somewhere in the middle. I hope that answers your question, Jean-Philippe.
Thank you very much. And just a reminder, you can ask questions to all of the panel participants now. In the white back.
Yeah, my name is Keshav. I'm a professor of computer science at Cambridge. And my question is broadly to the panel. And I'm not really part of the remote sensing community at all, but more sort of coming from the AI data side. When we have large repositories of code in computer science, our experiences of something called code rot, basically the funding is time limited, but the code lives on. And so if somebody is on a 3-year postdoc position or a 3-year research associate position, at the end of 3 years, who is going to take over the code? Likewise, if data is collected for a particular project past the project funding deadline, there's no motivation, no resources, no storage, no actually any impetus for that to be maintained, which is why you have a divergence from the data management plan and the actual data. So what we've learned is that if you need to maintain code or data over a longer time period, somebody needs to be responsible and funded for that. And to the extent that we have these goals of long-lived data, it must be associated with long-lived funding as well.
Thank you very much. And the question was for anybody in the panel. And I give the floor first to you, Helen, and then the rest can think about it.
Yeah, sure. So I think this actually very quickly cycles back to what I said a moment ago about the role of domain level repositories, because many of the domain level repositories have long-term sustainable funding, and their mandate is to ensure that data remains usable and available for reuse. And I think a lot of those repositories now are expanding their scope to include the algorithms and software, particularly when we're talking about generating models. And they are now increasingly becoming part of that research body that is, ends up in a repository. But I think there's also a case here for, open source, because if it's out in the domain, it's much more likely to be reused, recoded, and adopted more widely. And I think that adds to the sustainability. But I think we're still a little bit away from software repositories in the same model that we have for data repositories at this point in time. But I don't know who else on the panel wants to comment.
Yep, Kalamkas.
Thank you for the question. I'll try to at least contribute to what Helen said. So if you look at this question from the GEO Knowledge Hub perspective, as we already mentioned, this hosting capability, so the code itself can be stored. And in the presentation, I mentioned that clearly specifying the licenses, this will also help. And then additionally, I can add that in the metadata fields, we have creators and contributors. Also, funding organizations, so if it's a word or if it's some funded project. So probably clearly specifying all these metadata fields will help later on after the project ends, identify for whom will the code belong. But in the description, this can be facilitated with some of the wordings and how to manage this information or data after the project ends. So in the GEO Knowledge Hub, so everything stored in the GEO Knowledge Hub belongs to the provider and of course the GEO community if it's open, but also we have this restricted access. If we understand that not all data may be available openly, so this is also possible. And in the GEO Knowledge Hub, all the data and as the data can be different type of data, including the software code, doesn't belong to the GEO Knowledge Hub team. It belongs to the provider, the content itself, and the GEO community. I hope I helped a little bit to the question.
Thank you very much, Kalamkas. In the interest of time, there was one question. You, okay, you, sorry, Paula.
Thank you. No, I just wanted to compliment what Kalamkas responded to the funding part. The last question from Cambridge. Yes, I think you raised the question on long-term funding, and I think this is a very, very pertinent question, because what we're doing here, we're not doing it for a short term. We are doing it for a very long term. The ideal scenario, right? And the actual situation is that we are fighting for funding all the time. And so in order to be a sustainable infrastructure, in order to be a sustainable code, in a service, right? Because having this as a service to the community needs to be sustainable. Otherwise, I don't put my money in a bank that will disappear tomorrow, basically. So the only way to make this sustainable is that the entire GEO community is made of more than 116 members, more than 150 participating organizations, leverage the GEO infrastructure, the tools we have been describing here. They consider it our as a community. And so without having to reestablish a new platform, because we have the Opidor tools, without having to reestablish a new portal and so forth, let's put, I don't know, I'm thinking loud. There are many options, right? We're not going to do counting now, but there are many options to say collaboratively, instead of creating a new platform that I need to maintain, I leverage something that the GEO as collectively is supporting as a service, a GEO infrastructure as a service, open, community owned, and so forth. This is an issue will be discussed at the plenary on Thursday. Thank you.
Okay, a very short comment from Joe.
I believe we need to separate what is an active repository of a project that is functioning, whatever how long it is, and the long-term preservation of data. I mean, in principle, at least in Euro, we have this inspire that says that data should be close to the producer. So we shouldn't send the data to an external repository if we are still capable of maintaining it. If we cannot, then the solution of the offered here in GEO is a perfect solution. It's a long-term repository. I have no more money, so I at least guarantee that this is not lost. So that's, I believe we need to look for this equilibrium between, having control of our own data and understanding that we lost the control because we've lost the funding, so we preserve the data out there.
Yes, thank you very much, Joan. I want to close now, but I think you sort of helped me with the last wording here, because I was going to say that everybody in this room have some sort of love for data and data management. Otherwise, you wouldn't have been here. And I think that's part of the solution, that we are a community that will continue to work for it. And and in GEO, as you said, Joan, since the very beginning, we recognized that those who care the most for the data are those who are producing the data. And that's inherent in the GEO infrastructure that we are now evolving. And so that remains a constant. And I think that's also what I would like to say as a closing word here, that we need to stick together, share the love for the data and for each other in our common interest, I mean. And I think this is also the strength of the GEO community, that we do have this passion almost sometimes for doing this. And in that, we are helping transforming data into Earth intelligence. And with that, I will thank again very much the speakers. Thank you so much for this. We give them an applause again. And we have a few minutes for coffee, and don't forget a picture. Oh yeah, we will take a picture. So the speakers will definitely have to wait for the coffee. And but then the next session will be about the GEO infrastructure and artificial intelligence. And I hope that you have the powers and energy to stay with us, because this is the future. And I will repeat the message again, since we are here loving the data and infrastructure even, please talk to your plenary representatives. We need them to understand the value of what we are doing. So don't miss the opportunity while we are here. Now, photo and coffee. Thank you very much.
Good afternoon, everyone, and very many thanks for being here. It's 5 o'clock, it's the last session of the day, and we still see many interested people for this session, and we thank you for your enthusiasm and patience and willingness to listen to this session. So this session is about geo-infrastructure and artificial intelligence. And it is session number 4 of the Open Data, Open Knowledge Workshop 2026. And in fact, it is a very, very important session because throughout this session, throughout the speaker's intervention, we will learn, discover how artificial intelligence is a tool. It's not the end goal, it's just the tool to enhance the already valuable content that is provided within the geo-infrastructure, within different solutions. And through AI, we are able to enhance a number of features that are essential for Earth intelligence for all. So our first speaker is Felipe Carlos from the GEO Secretariat. Felipe will be presenting to you the GEO Knowledge Hub on steroids. Wow, that sounds a good title for 5 o'clock. And how large language model can support data knowledge discovery. So Felipe, without any further delay, the floor is yours. Thank you very much.
Thank you so much, Paula, and thank you everyone for staying with us. So I will be, as Paula mentioned, talking about the Geo Knowledge Hub and how we are using AI to enhance the search and discovery capabilities we have in the platform. So to start, this is just a recap. I already presented this today, but just to remember, the Geo Knowledge Hub is the digital library for the Geo community. So it's the place where we have all the content from the Geo work program activities centralized and preserved. And this is something I think it's important to mention. In the current, let's say, production or available version of the Geo Knowledge Hub, we have various features available, and those features and users can use those features to discover and access the content shared by the Geo community. And also, of course, those sharing knowledge are able to preserve their materials there. So, of course, the way we implemented the Geo Knowledge Hub is based on the Geo principles. The way we manage the metadata and also the files users upload there are user preservation friendly. So for each uploaded, for example, set of files, it's possible to assign a DOI, for example. So this is persistent and anyone can cite that, reuse, and use to access that as well. And in the context of discovery or to search the content, it is possible to use spatial search, so we can get content from a specific region, thematic search, so for example, exploring content associated with some geo-focus area or with some SDG, and many other thematic ways to search we also have. And of course, we have the possibility to search content using full text search and all the capabilities around this, this technology. But there is something, of course, interesting about the Geo community, and this is leading us to the use of new technologies. When we talk about Geo, we are talking about a very diverse community. So we have members and community members working in different domains. Of course, all applying satellite-based or in situ data to solve or to understand a specific environmental problem. Of course, GEO is also an inclusive community, so we always welcome all members and sharing different things. And of course, GEO is a community, is a huge community, so we are always collaborating and creating projects and initiatives together. And of course, with all these attributes, what we have in the GEO as a community itself is a massive and rich amount of data and knowledge. So as we have many members in a community interacting, we see the community producing a lot of good data, good knowledge, and the GEO Knowledge Hub is serving as the place to centralize all this information. But of course, as we have more and more content stored in the GEO Knowledge Hub, we want new ways to extract what is available there or discover what is available there, and also extract, for example, insights and get better results for what our needs. So to solve this issue and as part of this evolution in the GEO Knowledge Hub, one of the things we are doing is introducing these LLM-based features. And this is just to show few ways we can use LLM in the search context. Of course, one way is to use LLM to extract, for example, the intentions of the user, and then use these intentions to refine the search and the results. Same for augmented query. So users is querying something that is sometimes vague. The LLM can help us in increasing this query, and then of course get showing better results. Another way is using this subquery. So based in one user query, we are able to create multiple queries and then search multiple times the content in the GEO Knowledge Hub using these like various subqueries, and then we show a summarized result. So this is also a way to enhance the way we are searching content. Of course, semantic search using embeddings produced by LLM, and also use the LLM model to evaluate the results. So the model will check the content from the search result, for example, and extract some insights, some answer for the user query. And our goal was to use those technologies and apply those to the GEO Knowledge Hub. And of course, the principle is to keep things affordable and sustainable. So we don't want to have a complete infrastructure to run these, for example, on premises. But at the same time, we want to keep things, of course, open source and always transparent. There is something I think it's important to say, since before I show all the things we are implementing, we are not creating new LLM models. We are using models that are available out there. So we use those models and can be small models for few activities, self-hosted, or for more complex activities, we can use models from these big providers available. And then basically this is the technology we want to use. And now I would like to show to you something very quick about building context for AI and how we are implementing this in the GEO Knowledge Hub and why this is important for our goal to have better results. So when we go and use an LLM in a, let's say, simple way, we basically ask something. This goes to the LLM, and the LLM will produce a result. The problem with this, let's say, simple approach is we ask the LLM to produce the result. And when we say produce, it's invent. So this is why we have sometimes the hallucination and all the problems we already know. Of course, you see this, like many providers, they're already trying to create ways to solve this problem. And one of the ways we use to solve this is building this context. So this means before I go to the LLM with the user question or with the user query, what I do is build a context. And in this case, build a context means I go and search for the for information in places that I already know. So for example, in the case of the GEO Knowledge Hub, before I go to the LLM, I can check packages associated with the user queries, or maybe services, or files, or databases, all things associated with the user query, and then I use the result of the search as part of the input for the LLM. And then we put together as input for the LLM, the user query and the context we build using all those services. And this way we reduce the amount of hallucinations we have. And for the GEO Knowledge Hub, the way we decided to implement this is using services. So to build context and like integrating as much services as possible. So here is the list of, we have more than 20 integrations already implemented so far. But basically, to build this context, the idea is we have a kind of a way to detect the intention of the user in the first place. Then we select what are the integrations that better fit the user needs. So if the user is asking about, for example, in situ and user and data requirements, then maybe we can recommend GREX, for example, and knowledge packages introducing GREX. Same for a user who wants to know about, I don't know, learn something related to agriculture. We can recommend Geoversity, for example, with courses there. And for example, tools with the OSGeo Observatory and so on. So the idea is we build the context using services provided and available in the Geo community. And there is one specific thing about packages and resources, and I think this is important to mention, because of course, as we are integrating many services, there is something that is very important, the standardization in the metadata level. So for all these services, what we are doing is trying to keep everything using the same metadata schema we use in the GeoKnowledge Hub, which is the DataCite metadata schema. And basically, when we have these standardized, it's easy to manipulate these to create the context for the LLM. And one of the things we're also doing is associate knowledge packages and knowledge resources with standardized vocabularies. For example, associating information about what are the satellites the packages and the resources are using, essential variables like climate variables, agriculture variables. So then when we use one of those packages or resources as part of this context, we have a lot of information associated with those packages and resources. And now I will show very, very quickly a few examples of results already implemented. First is using the semantic search. So from that list of features, I will show few. Using this semantic search, when the user go and search, we show, of course, the list of results, but we also show this overview. Then user already know what is available in the results. Of course, we show the list of services we are querying. So as we are integrating with many services, we show the list of packages, resources, also data cubes, content available in the marketplace, the code tutorials available, and so on. All of those stuff from the services we are integrating. And of course, the results of the search itself using semantic search produced using LLM embeddings. Then there is another feature we are implementing, because as we have the data model well organized, we can implement a lot of different ways to LLM consume this metadata and content. Another way, for example, is implementing this deep search. So this is basically implementing an agentic search. And basically when the user asks something, so in this case, I'm asking forest monitoring. What this agent is doing is basically querying multiple times, multiple services we are integrating. And then this is just to show like the integrations, like the query is working. And then it creates categories with the results. So this is the LLM getting the results from the sources and categorizing them. And when we open one of those categories, we're able to see all the results there. So you see, it's a different way to see the results, and of course, use the content and get more information about the content available in the GeoKnowledge Hub. Same for, and this is just to show the sources. So everything in the GeoKnowledge Hub, when we are using AI, we keep track. So I will show one slide in a few seconds. And we also keep like the sources. So when we have some affirmation or some text about something, we keep the source from where that thing came from. And then the chat, this is very quick just to show, it's also based in agent implementation. So when we ask something, it is using multiple agents to query multiple services. So for example, to integrate the information from GREX with the information from FAO-STAT, for example, and the GeoKnowledge Hub. So we have 3 agents working together to produce these, like the answer the user is asking. So for example, here I'm asking like a table with agricultural applications available or courses associated with agricultural applications. So you see this content from Geoversity. And this is very quick, like the sources, just showing the trace as well. So we are able to control all steps the LLM is exploring. And last few slides, LLM can be very expensive, we all know. The way we are dealing with this is for simple cases like summarize a simple text. We use local LLM. To something more advanced like deep search or chat, users bring their own key. So they put their keys there and then they pay for the exploration. And this is one extra thing just to show we're also able to create packages using LLM. So user just upload a lot of files and the LLM evaluates and define the structure of packages, already creating data, metadata for the package and resources as well. So basically that's what I have to share. Thank you so much.
Thank you very much, Felipe. This is really the GeoKnowledge Hub on steroids. I would like to pause for 1 minute to make some reflections here. Throughout all the ODOC sessions today on the in situ, on the National Knowledge Hub, on the data sharing, data management principles, and the different tools and the governance for the geo-infrastructure, we heard key words. And those keywords were co-design, co-development, community-owned, and trust. So trust is what is, I think, the keywords that is critical for trusting the resources, the outputs that the LLM, the AI, is providing as output. You know this sentence, garbage in, garbage out. And this is what we are working to avoid, because the community is the owner of the GEO infrastructure. In GEO, we have 117 member states, 162 participating organizations, and a number of GEO Work Program activities for the GEO Work Program who are contributing to the GEO infrastructure. And once we adopt the data management principle, the FAIR, the trust, the care, and all the essential elements, the data licensing, the trust in the co-development becomes the key word for being able to trust and adopt what the GEO infrastructure is providing us from this open, transparent LLM tool that has been implemented in the GEO infrastructure. So this is exciting, isn't it? Yes? Yoo-hoo! So the work didn't finish here because the team has been collaborating with EOGPT from CEOS, NASA, in going further, using artificial intelligence in another way. So again, Felipe, on behalf of Dave Borsch, Director for CEO's System Engineering Office, who couldn't join us here, and from his team, Felipe will be presenting the work that has been done with this team. Thank you. Again, you need some water, Felipe.
Yeah, thank you so much. So it's a pleasure to be presenting this initiative as well. So this is something CEOS is already running quite some time now. And here today I will be presenting some new results they are producing and integrating and using content available in the GeoKnowledge Hub. So first of all, I think it's interesting to see what is EOGPT. So EOGPT is a platform where you have the possibility to use a very high-level chat-based interface to produce analysis. So imagine as you have, for example, your ChatGPT, but when you ask things or more specific questions about a specific data or a specific event, instead of just generate and create random answers, it is actually creating the code, executing the code, and showing the results to you. So it's in fact a tool that helps you to produce the analysis. And of course, when you are discussing or chatting with this platform, it is hidden all the complexities to, for example, orchestrate the execution of multiple processes, for example, or to access data available in multiple providers. And of course, the vision, the approach of the OGPT is to have this unified conversational environment so we can do all the analysis there. So I was exploring and using the tool a few days ago, and it's very interesting the way you can just ask and then it produces some result and you can keep iterating until you have the result you really want or you really need. So it's really focused on this, it's strong focus on this user interface. So they're always trying to enhance the user interface with new features. And I will show in a minute how this works in practice. And all the things they are developing is always interactive. So it's possible to, in every step of the tool in the execution, to ask something different, to change the execution road, for example, and to produce the result we really want. And to implement this tool and, of course, have a trust in the results produced, EOGPT is using what they call this modules registry. So basically, instead of let the AI generate the code, for example, to do a NDVI time series analysis, they have this module registry, and basically for all these main features or main analysis, they have already curated Python code and then the AI can use. So for example, to access a specific data provider or to do a specific analysis, they implement specific functions in this module registry. So this way they avoid the LLM to start like go crazy and create random code. And this is just to show how it works. It's you have a query. So for example, I want to know NDVI trends in a specific region like South Africa from 2016 to 2020. So this is my query. The first thing the platform will do is analyze your intention. If your intention is to do like computational thing, it will basically for this option, create the code, check for bugs, and then execute for the result. If you are asking for something like I want to change the map, you can also use the chat base to change the map, change colors of the map, change the layers, or if you want to do a web search, for example, or if you want just to reply for something the LLM is asking you. And of course, this follow this event process, and you have the result on the main page. And for this module registry I was talking about, is where all this computational process works. So when the user is asking something that requires analysis, the tool is basically going to this module catalog, checking what are the modules available and what are the modules the tool can use, and then the tool basically create a script using the functions available in this module catalog. And for large, for example, pipelines, the tool is even defining multiple like tasks and steps. So this way it's easy to understand what is going on step by step. And of course, if there is some error, the user can even guide the LLM in a specific step if required. And here I have some results, some examples to show how the tool works in practice. These are more like slides to show, and I have a video after. For example, this is a fire analysis. So they basically ask for the EOGPT. Run an analysis on the wildfires which happen in bi-directly and in a specific like date. And basically the platform figure out how to access the data using like a spatial asset catalog, use that data to calculate NBR and show the result in a plot. So it's one example. Another example is using this temperature dynamics. So same idea, just a simple query like compare and contrast the daily temperature of San Francisco and Walnut Creek from 2020. The platform will manage how to access ERA 5 data and how to evaluate the time series and plot in a way that I'm able to answer my question. And same for example, drought analysis. So this is something from southern Brazil. So same idea. I request something, the tool figure out how to access all the information and provide the results. And here I have one example. So this is the tool already running. So basically, this is one example of analysis in a very agricultural area in Brazil. So basically here, we requested a characterization of this region, which is Luiz Eduardo Magalhães in Brazil, from 2015 to 2024. So as you can see, when we request this, the tool already zoom in to the area I requested and define a list of tasks, and then start to evaluate and generate code, and then producing the results. As my query was about characterization, the tool will produce a lot of different results. For example, with the spectrotemporal profile of the region, like some RGB image, and other things as well, as I want to characterize that region. So as you can see, this is very interesting. And if we keep, for example, asking more things and evolve, for example, I have here one time series, and I want to compare if in the complete time series we have, I don't know, similar year in a grouping activity, for example, or for a land use and land cover classification, this is also working. And there is also something very interesting to mention here. This module, they are using the GLAM system. So GLAM is a data analytical platform. This is from the GeoGLAM community. And based on the content available in the Geo Knowledge Hub, the EOGPT team was able to integrate GLAM into the EOGPT. So you see the tool is also possible to extend. And this is because you only have to register a new function, and then the LLM will consume and produce the results. So this is just showing extra things, like from the chat, it's possible to extract the figures and of course customize the figures. So here I have these blue bars, it's possible to change the colors of the bars, or for the time series, the same, apply some smooth in the time series, for example, and so on. So you see, it's the main thing of the platform is the chat. So we always do the complete analysis using the chat as the first place, but we have auxiliary tools to help us to customize the look and feel of our result, and even the way we are presenting that final result. So this is basically it. This is just to mention some future work. They will continue to validate the tool and improving these possibilities to customize these visual like representations. And all of this is because they want to make this tool open source to the whole community mid-2026. So in few months, this will be available. And of course, once available, we will be able to, for example, integrate our own modules there. And there is also something, it's not in the presentation, but they are already implemented, which is the possibility to include skills. So apart from the like all the code available in the platform itself, you can provide extra skills, which is basically a file describing a specific knowledge or information, and the tool is able also to use that as part of the analysis. So this is also something interesting. And here, a list of some publications. They will be in Argus this year. So if you want to check, they will have a presentation there as well. Thank you so much.
A very well-deserved applause here, Felipe, and congratulations to all the CEOs team and EOGPT. This is amazing. Yes. What we heard in the past years, that the geo-infrastructure, yes, should do preservation, should do enhance discovery, should enhance access, should enhance reuse. But what we are witnessing now with this presentation, it is an additional feature. It's providing those analytical services that could provide support to GeoWorld program activities or to any user out there. And this is, well, raise your hand if you think this is Earth intelligence in action. Yes, good amount of hands. Excellent. So we will continue our journey in exploring artificial intelligence with Dr. Yifeng Ban. Dr. Yifeng Ban is a professor and director of geoinformatics at the Royal Institute of Technology in Sweden. And her research focused on AI-driven Earth observation for urban mapping, urbanization monitoring, and disaster management and climate resilience. We're extremely honored to have you here, and please.
Yes, thank you, Paula, for the introduction, and really glad to be here and see so many of you so late. And also nice to follow up with Philip's presentation because this fits right in. I'm here wearing not the KTH hat, but the AI for EO enabler hat. Tell you a little bit about AI for EO, how our activities can, benefit open data and open knowledge, and our collaboration with the GEO Knowledge Hub. Yeah, next, please. Yeah. Okay. Yeah, thanks. So, how many of you know about our enabler? It's a cross-cutting enabler. Okay, well, I know some of you belong to our group, great. But for the majority of you don't know, our aim is to strengthen the integration of AI into Earth observation by connecting AI experts, data science scientists, developers, users across a variety of communities in order to accelerate adoption of trustworthy and scalable. So Paula already highlighted the importance of trustworthy, but I would say here scalable is also important because our users are at local, regional, global scale. And how do you scale from local to global? So this is very important. And another aim is really we're a collaborative platform to foster cross-discipline, cross-sector exchanges, knowledge sharing, capacity development, and responsible use of AI. So this is really aligned well with the Knowledge Hub's goal and objectives. So I'm not going to say the specific objectives, but for the time, I just want to say if you are interested in joining our group, this was from some time ago. I think we now have around 150 plus members, and we are growing. So if you scan the QR code, you can join right away. So we have 4 different working groups. The first one is datasets, tools, and use cases. Basically is instead of AI agent, looking for, what are the good tools and things, we have experts who are helping to collect. So human, maybe in combination with agent. Then to collect AI-ready, application-ready data sets, and also different open source AI tools. You can use even not open, like Alpha Earth, but you can still use. And also give examples of use cases to inspire people or more people to use AI in their applications. So we have 2 colleagues, Claudia and Charlotte is the first group. And then we have another group who organize workshops, webinars, training initiatives, and also challenges, AI for EO challenges I will tell you about in a little bit. And we have my colleague Andrea Nasati and Valerio from ESA. Then we have a group policy, law, governance, and ethics as trustworthy AI is really important. We have Thomas, who is a law professor, and we also have Torsten Jelinek, who is also expert in this field, leading this activity and also, making sure we are using AI responsibly. And then the last group, co-led by myself and Padram, we're looking at to draft white papers, policy briefs, to summarize what's going on in this field to disseminate to the broader community within GEO. So just examples, we had webinars that Valerio and Yuru gave a webinar about there are many different foundation models and which one is better for which application. This is really important. We want to benchmark it. So we had a benchmark webinar to inform user community. Another one, actually, Professor Keshev is here from Cambridge. They developed the Tessera foundation model, and they also have given us a webinar. We are continuing to organize webinars. And the next one is coming up in June. And another important thing is we're developing white papers. Tomorrow, we will be announcing one, is unlocking Earth intelligence for all AI-driven Earth observation. What are the opportunities, challenges, and future directions? So tomorrow plenary, I will tell you a little bit. We have a draft ready. It's too long. It's like over 200 pages with 40 authors. You'll find out more, and I will provide a link to the white paper. And we have another actually white paper in the development is responsible AI in EU. Really, how do you from policy, pixels to policy? So this is under development. So we also collaborate with other organizations. This is a challenge co-developed by us with ITU, ESA, and also my university. It's called the GEO AI Challenge. It's been announced, and I think you can still join if you're interested. To look at, you will hear more. I have a colleague who will talk about it at the at the AI for EU session tomorrow at 2 p.m. So basically to evaluate different foundation models for land cover mapping and also height estimation. So join the challenge if you're interested. So now our collaboration with the GEO Knowledge Hub, now we recently started. We now have a community space. So we're the newest one. That's why we're on the top, not because we're good. We just started. But the idea is really we have a lot of materials and knowledge. How do we share with the user group? So for example, data sets with our collaboration with a sister organization, IEEE GRSS, who is also a member of GEO, they have already large data sets, catalog of data set. How can we link that data set already existing with GEO, and people don't have to look for it, or we don't have to reinvent the wheel? So you can search again, through maybe application domain, we focus on geo-focus areas, as an essential climate variables, SDG relevance. Then what kind of data, geographic location, you can search for your region of interest, different sensors, and are they machine learning, deep learning ready? So you can also look, it's like time series versus, a single timestamp. How can you access this? So this is something we've been looking at. So, what is for, where, and when, how is it captured? Can I train on it? And where do I get this data? So it's going to be a link. We're not going to bring the data set to GEO Knowledge Hub. So just an example, we recently published 2 data sets in the Nature Scientific Data. So they are deep learning ready, and they are also, we have benchmark AI models. The codes are open, so you can use. And we also thought maybe you already know all the data set. We actually maybe the most urgent need, if I'm wrong, tell me, is the tool inventory. What are the codes, models, feature embeddings are currently available, and how do I use it? How do we help the community to choose what to use? And where to use, when to use. So that's actually come with, we have a benchmark that is also open. We have the Living Book or IFOEO white paper, but the paper become a book. So we call it a living book, so we can always modify it. So that will provide guidance and support to the user community. And we will have a bunch of use cases as examples and inspirations. So that's all from my side. So welcome to the session. I will talk about the more details about the Living Book IFOEO tomorrow morning, and we have a full IFOEO community event in the afternoon at 2 o'clock. Thank you very much.
Many thanks, Dr. Yifang. We are very, very happy to be able to collaborate with AI for You. This is a crucial working group within GEO and fantastic work ahead of us. Our next speaker is Dr. Lan Wu from Development Research Center for Surveying and Mapping in the Ministry of Natural Resources in China. Okay. And Dr. Lan Wu is very active in initiative for data standards, development, application, capacity building, and the cultivation for an inclusive ecosystem. She will be giving us a very, very valuable presentation from Earth observation data to knowledge, building an AI enabling inclusive ecosystem. Thank you very much. Welcome.
Thank you, Paula, for your kind introduction. And good afternoon, everyone. Before, I guess I'm the last presentation, last speaker, so the sequence change. And I hope after my delivery, everyone is happy. Just get their takeaways. Now I changed. So
yeah. I am sorry, you're not the last speaker.
Oh, yeah, before.
We have so two more after you.
Okay, thank you.
Okay.
I just want to, after my delivery, everybody is happy to get your takeaways. Now, okay, just wait two more. Thank you. I want to take this opportunity to share China's journey of transforming EO data into knowledge by building AI-enabled inclusive ecosystem. I will briefly take you through what's going on in China, what's the situation, what's the current progress we have made, and highlight some showcase, then outline next steps, what we will do next. Let me start at numbers. From these slides, you can see we have a lot of data. I just refer to remote sensing satellite and navigation satellites. Only last year, we added 101 new satellites, including, among them, over 30 high-resolution satellites. That means even smaller than 1.5 objects can be detected. And we also, besides remote sensing satellites, we also have navigation satellites, already 50 in orbits. That means we will never lose our ways. Navigation, always navigate. Actually, it's not just technology growth. Our industry also booming. In 2024, our geospatial industry hits $120 US. With a highly mature industry, extensive supply chains, and endless real scenarios, China is becoming a vital testing ground and massive markets for the global geospatial world. Consequently, in last year, UNGGIM launched an ambitious plan. That means will establish the World Alliance for Geospatial Industry in Deqing, China. Its mission have four missions. One, boost EO data applications. Second, bridge the digital divide. Third, catalyze the global geo industry. And last, support UN SDGs globally. Our commitment remains still that no one left behind. However, we still face significant challenges. That challenges ranging from data sharing and practical applications to industry chain development, both technically and institutionally level. That's why we choose AI. We embracing AI. We are seeing three big shifts. One, data democratization. That means you don't need to be a coder or a professional technician. You can analyze data using AI. AI is opening doors for everyone. Second, knowledge co-creation. We are breaking down silos. It's about sharing algorithm, not just holding data. Third, innovation. We don't just want a pretty digital twin. We want a model that understands the physical world and can actually predict the future. That exactly fits with the GEO post-2025 strategies. How do we execute it in China? Normally in China, we formulate strategies in advance, then implement consecutive 5-year plans. Now, currently, we are rolling out 50s. Through all these 5 years plans, we have one big shift. We now treat geospatial data as a factor of production, just like land or labor used to be. And we are weaving space, air, ground, sea perception into everything, from disaster relief to social governance. Think of it this way: EO data and geospatial intelligence are the new infrastructure for China's national security, environment, and digital economy. That's our ecosystem. Here's the thing. I give you an example of our Ministry of Natural Resources. Because we believe data only creates value and generate knowledge when it works, put it into use. We built a full cycle, you can say, acquire data, integrate other thematic informations, and then feed it into AI apples, whether through the protecting farmland, planning cities, and enforcement of our laws. AI is actually part of our daily life and daily works. To convert data into knowledge, we rely on solid infrastructure. That comes our 10D2 map world, which is launched in 2011. 10D2 is actually China's national public geospatial service platform, providing authoritative, unified, and efficient services. Its core-mission to open sharing and serving economic and social development. Now its scale already over 1.4 million registered users and handling 1 billion API. Okay, I will be quick. Requests daily. So I will leave all these details. Let's look how our 10D2 functions in 3 scenarios, major 3 scenarios: smart cities and government service, almost expanding to most of our administrative levels, and also enterprises. That's very important. That means we support the private sector. The private sectors also have been involved. And moving forward, we are focused on three things. One is integration, building a one-map stop system so everything talks to each other. The second one's data circulation, treating data as a true asset. We are building trusted data spaces, just as Paul mentioned, trusted data spaces to make sure data is high quality and traceable. Innovation and cooperation, developing advanced spatial temporal tools to extract deep insights. We aim to provide high-level international public goods and contributing our expertise to global sustainable development. We are now building the next generation 10D2. The goal is to create an AI-powered spatial temporal foundation model as intelligent bedrock at a national level to be the bedrock of digital China. Ultimately, we aim to build a model that truly understands our planet, capable of automatically future extraction, change detection, and situation awareness. To wrap up, I'd like to share my vision and the GEO strategy. Institutions as GEO and UNGGM must unite to advance Earth intelligence and SDGs. To bridge the gap, UNGGM already set up the WAGI because we believe AI is not only advanced technology, AI is also create the era of industry. So industry is very important. To achieve all these goals, maybe I list 4 issues, maybe more. To my observation, I trust we have to work together to give our planet a brain and to make Earth intelligence a fundamental pillar for everyone, for everything, and everywhere. Thank you.
Thank you very much. Very insightful presentation, very insightful way forward. I think we all share this direction to provide our planet with the right tools to preserve it as much we can.
Yeah, I also wish, just as you suggest, together. That's
Yes,
all. Yeah.
exactly.
Yeah.
This is why GEO is a strong community. We're here together to work together.
Yeah, that's why we sit here together. Thank you.
Thank you. And we welcome our next speaker, Margherita Di Leo, from the Joint Research Center of the European Commission. Margherita will be presenting to us AI-assisted metadata editor, intelligent metadata creation for geospatial datasets. Margherita is an environmental engineer with a PhD on method and technologies for environmental monitoring. And her current research entails artificial intelligence, synthetic data, and data governance. We're very happy to have you here, Margherita. Thank you.
So we all agree that data without metadata is unusable, but for some reason, nobody wants to create metadata because it's boring, it's costly, is inconsistent, and largely manual. The creation of metadata is a tedious task. And so it's a known bottleneck in SDIs and in data management. Also, there is a plethora of schemas, there is heterogeneity, different standards, and across datasets there is the content inconsistency that makes data hardly discoverable when one is to search for data sets. So we created this AI-powered metadata editor to address all these challenges with a unified schema-agnostic metadata pipeline. With this tool, metadata are automatically extracted from a dataset and companion documentation with a human-in-the-loop validation. And I'm happy to tell you that just today we got a clearance from our internal intellectual property review to publish it as open source. So you will soon see it on Code Europa EU. I will briefly describe the approach, how it works. In order to understand the logic, we recognize three kind of attributes in the metadata. Type A is the descriptive metadata, which is text-based and is suitable to be generated through LLM. Type B attributes are the technical attributes and can be extracted from the dataset itself. So it's, for example, bounding box, coordinate reference system, spatial resolution, and so on. And finally, type C attributes are the properties defined by the data provider organization, and usually they can be reused across multiple data sets from the same organization. So they are declared by the user via a file, a JSON file. How does it work? So the tool works in this way. It takes as input the data set that can be provided via upload, or it can be also published, so you can provide a URL, or finally you can, even if it's big and it's not published, you can run this utility tool, GDAL-info or GR-info, and you can upload the output. Then you can you upload the accompanying documentation of this dataset that can be technical reports, publications, any even README files, whatever you have that describes in some way your dataset. And finally, you can upload also existing records of previous metadata that needs enrichment or needs a change of schema, because this is a schema agnostic, so you can upload any schema as input. So the pipeline works like this. First, the type B, the technical metadata attributes are extracted using Python libraries. And then also type C, organizational attributes are parsed. Then everything from the documentation goes into a RAG with a semantic search, and it's available for queries from the LLM. And the type B and C attributes are also fed into this information, so that the type A attributes, the textual attributes, are most complete as possible. Finally, the metadata is presented to the human for review, can be changed, edited manually, and can be validated and exported. This is how it looks like, how it's presented. So in this instance, you can see there is a section for API credentials, there is also a section to upload your own template, your own prompts, okay? Because there are pre-existing prompts, but they may not satisfy your organization, so you can change them. So you download the pre-existing, you change, and you upload your own. And finally, you can see the green section is the where you upload the organizational attributes. It's a simple JSON file that, again, you can download, compile, and upload. So here, the first section on top is where you upload the data set, and the section in the middle is where you upload any supporting document, as we mentioned, and then you hit the extract metadata button. And this is how the output is presented to the user for human in the loop validation. So user can edit, as I said, fields manually, and the fields have a topological dependency. So there are some fields that are more complex, like for example, the descriptions. They are modified when some dependencies change. And this is the other part of the output. So you can use this in three operational modes. One is the creation of metadata from scratch. The second is schema migration from any schema that is pre-existing to the target schema, that in this case is a GeoDCAT AP, but it can be expanded to support other schemas as well in a modular way. And finally, there is a metadata enrichment. So if you have incomplete metadata, you can use the same logic to enrich metadata, but there is no need to choose because the operational mode is decided according to the input of the user. So no problem here. And this is a companion study that that has been submitted that it describes good practices on how to create prompts in an effective way. And the most important thing is that we define a template that is very influential in order to have a structural compliance across multiple metadata. And we use explicit placeholder as a safeguard for hallucination of the model itself. So we practically request to the LLM, if this information is not available for you, you explicitly say not available. You don't fabricate it. So in this way, we notice that there is an improvement in this regard. And finally, it is important to stress that the documentation quality that comes that accompanies the data set is key, because if the information is simply not there, it won't be extracted. So these are a few key points, but I think I already covered most of them, that it will be released as open source as soon as I can publish it. Then it addresses both schema level interoperability and content level harmonization. It is validated through a systematic prompt engineering study. The template structure and the explicit placeholders are the most impactful design choices. Then there is a documentation dependency because the output quality is dependent from the documentation quality provided by the user. And okay, there are a few improvement that can be made in order to, let's say, improve scalability and parallel sessions and so on, that I don't want to bore about. So, thank you.
Thank you very much, Margherita. Tell us as soon as published because we will integrate. And for the community, you have no excuses now. Metadata, automatic metadata production, data management plan tool. So we are getting the right tools to serve out the way we have to go. And this is exciting. Thank you. This is a very, very interesting release. We have had a number of announcements of upcoming release of publications and tools. This is very important, and I think this is a highlight of the work we have to keep going. And I hope you're still there, full of energy, because our next speaker is the last speaker. Is Jean-Philippe Montillet. And Jean-Philippe will talk about geodata liability. And this is very important. What does it mean, geodata liability? So from open data risk to accountable Earth observation. And Jean-Philippe is a senior geoscientist, climate change expert, and data strategist at WRC in Davos, Switzerland. So his work is dedicated to ensuring that critical climate observations remain robust, scientifically sustainable, ethically governed for global stakeholders. We're very, very happy to have you here, Jean-Philippe, and the floor is yours. Thank you.
Thank you for the introduction, and thank you for sticking around. One thing is I heard during this session is about AI hallucination. It's good because that's right in the middle of this presentation. I'm speaking about geodata liability. And this is a concept that I'm trying to discuss. Well, we started discussing in the group, the subgroup on data and law policies. And this concept sits at the intersection of Earth observation, artificial intelligence, and financial accountability. And during this presentation, I'm trying to answer a little bit this question: who is responsible when Earth observation processed by an AI model lead to a wrong decision with financial and perhaps public safety consequences? Thus, the presentation is following these 4 chapters. Thus, first, I will quickly remind what's happening in the Earth observation market. Then the chain of trust, it's when we process raw observation down the line to policies and data products, etc. And then I will discuss about when the chain breaks with a quick example. And finally, what is geodata liability in the way that I have started defining it. And that is just a work in progress, of course. All right. Thus, the observation market. The global geospatial market projected to reach $1.4 trillion by 2030, driven heavily by rapid advancement in Earth observation, enterprise location-based services, spatial analytics, and GEO integration. In 2025 alone, it already represents $102 billion, growing rapidly to 17% annually. Earth observation accounts for a significant share of this market. But the real story is the data pipeline, what I'm showing it. At the beginning, we have satellite data, and then we have the processing where we extract the knowledge. And from this knowledge, we have financial trigger. And here we are speaking about automated payout for parametric insurance, carbon credit, etc. And then from this trigger, we have the green capital. Thus, here we are speaking about bond offset insurance product. The message here is we are deploying capital at unprecedented speed on a foundation that is not fully audited. We are monetizing this data much faster than we are securing in scientific integrity. Okay, the chain of trust. This is part of, well, the slide is a bit broken. This is part of a picture that we published in a paper early this year with some of my colleagues. At the top, we have the raw data with remote sensing technologies, the instrument on satellite, in situ sensor. Then what we have the storage. So we have the server, the big data center, server, classification, data governance. I will speak in the next slide about that. And then the processing, AI, advanced analytics. And this is where the real scientific value is added, but also where the greatest risks are introduced. And finally, we have the product. Thus, in this product, we have drought map, risk flood map, capital deployment, and also early warning system for the public safety also, and capital deployment, of course. All right, as we can conceptualize this chain of processes in this way, thus we come back to data collection, the raw data, and then data integration. Here, in data integration, the most important thing is the data governance. Data collection, data management, and data quality. And data quality, we are again speaking about the principles that the GEO has been advocated for many years, fair, care, and trust principle. Also, there is data ownership. And perhaps I should say also a few words in data management, the metadata. We have discussed this about this afternoon, and even if it's boring, it's very important, especially in AI. And then the yellow box here is a stakeholder use analysis. Thus here is the processing, government, academia, industry, finance, and finally the product. Okay, I'm going a bit faster. Okay, thus when the chains break. Thus in 2023, a joint investigation by the Guardian on its side found that 90% of the rainforest carbon offset certified by a major certifier were phantom credit, with AI-powered geodata model playing a central role. I'm not going too much into the detail of this study, but on one side we have geodata, the model was not accurate, but then the problem is we have an assumed validity of this model and from the buyer, and that's in this story, this independent verification has not been performed or never been performed. And then comes the liability transfer, and this is the big issue because it shifts from the data provider to the buyer, and triggering litigation and greenwashing claims. And the key question is, when an AI-derived climate product causes financial harm, who is liable? And nobody can answer this question right now. Okay, this is just to summarize. On one side, we have the Earth observation standard. We have the robust. We have the GEO principle. And there has been lots of work on it for many years with the metadata, etc. And then on the other side, we have the AI model risk. And here we have to reinforce that AI model are statistical association. And if there are biases in the data or in the model, then we can have AI hallucination. That's what we have discussed previously. And thus there is a need to discuss, to separate the signal from the noise, if I can say it in this way. Thus distinguishes true information from potential biases which can harm businesses. Okay, I'm going a bit faster. And let's go to what is geodata liability. It's a systemic global risk threatening the integrity of trillion-dollar climate investment and critical policy decision. As financial market and government increasingly rely on AI-driven Earth observation to monitor net zero goal, the danger of making high-stake decisions on non-validated data is growing. New scientific standards based on physics-informed deep learning and metrological standards can generate the tool needed for this audit. And then we have the transition from open data to trusted data with accountability. And the takeaway is geodata liability is not barrier to innovation. It is a safety infrastructure that makes a $1 trillion digital climate economy safe. And about compliance, this is just some idea, of course, because it's a work in progress. Thus, what do we have? We have 4 pillars. We have the traceability, calibration chain from instrument to output, data provenance, that is related to what we discussed before, metadata, fair trust care principle, conformance, and that is something to think about it is, does the output meet the defined specification? And uncertainty. We have to discuss and define this. And then the fit for purpose, a standardized uncertainty statement that user, engineer, policymaker, bond issuer, etc., can access independently. So this fit for purpose is almost a certificate, which could be delivered when auditing the whole data pipeline, and especially the AI black box. And that is my last slide. The geodata liability is not a constraint on the digital climate economy. It is a condition that makes this trustworthy and therefore sustainable. So here I take possibly three businesses, and for the sake of time, I'm not going into it. But trillions in green finance, parametric insurance, and climate adaptation fund are allocated based on AI-driven climate product, and no one can verify the uncertainty inside them. That's the end. Thank you very much.
Thank you very much, Jean-Philippe. Very, very interesting conclusion of the AI session. We need this open data, open knowledge, trusted data, trusted knowledge, absolutely. So I would like to open the floor for any question, intervention. I know we are a little bit above the time plan, but if you're still here means you're still interested. So the floor is yours for question and intervention. Carol, welcome.
Hello, I would like to ask Felipe, you mentioned the cost for the LLM services. Did you make some tests, run LLM locally? Because there is a big option of possibilities, and this is very what we are trying to do now.
Yeah, thank you so much for your question. So we, in the current version of what we are developing, we have 2 modes of execution. So for authenticated users, we offer the possibility to run a model available in the GEO infrastructure. So then it's running like locally. Of course, it's a small model, but it's possible to use to perform the tasks. But if the user want to have a big model performing the task, then they can provide their own keys. But we are already using these local models. And to run it, we are using VLLM and other technologies as well to make it use, for example, GPUs or CPUs as well. So we have it.
Which local models are you using?
Sorry?
Which local models are you using, if you can tell?
Oh, for the models, I think we are using, I will not remember the names, but I think it's Gamma or others as well. Like small models, I remember what we used as definition was with 32 gigabytes of memory, it's possible to use something, a model with something around 6 or 7 billion parameters. So this is those models we are exploring. So these small models, something like that. Yeah. Thank you.
Joan. Oh, okay. Sorry. Please. I don't see. Yes.
All right. Anyway, then for the the JRC AI metadata stuff. I'm interested in the data quality part. Did you try it on data quality? I can just tell you my experience that as a human trying to read the documentation and transform into standard data quality documentation, it's not trivial at all. So I could benefit from some help.
So we didn't go that far because we are just releasing it right now. So it's a little more than a prototype. Okay, so we really need testing on real data. So we welcome feedback.
Quick question about bias. Where we leave it, and are we going to be accountable of it, and who is going to be accountable for it? Because all the geo models at the moment has more data from the global north than the south. So I assume that all the answers from the global south, if I ask, is going to be constructed based on data from the global north. So where we lift the bias of the information that exists right now.
Before giving the floor to Dr. Yifang, I think there is a very, very important reflection here. The importance to keep open data and open knowledge open and trusted with strong metadata means knowing who is providing this and going to have this AI layer on top means that we know what goes in and what goes out. And what goes out can always have a traceability. And so this is critical for the liability. The traceability is critical, and we cannot have a black box, which we cannot control. The AI cannot be that black box provided by a third party that we cannot control, because then we have no understanding and no probably trust on the output results. So the input data and output data can always have to have that traceability and source control. And please.
Yeah, that's an excellent comment. I think bias is one of the major challenges using AI in EO because we don't have as many well-collected labels about buildings, wildfires, you name it. From the Global South, I actually been talking about this since several years ago in different forums. To me, we need to be mindful when we transfer, the models training in the global north to global south, and you obviously have to validate your result really thoroughly. I'm not saying you don't have to validate here, you also have to validate, but be more mindful. Another thing is I've been trying to lobby the colleagues from the global south help to generate more reliable labels, either, from ground-based sensors, UAVs, whatever we can get hands on. We need more labels from global south.
If I can just address this question about geodata liability. I mean, this is true for any kind of big data, right? It's not just Earth observation data. In fact, Earth observation data is probably better than others because the data is being collected in a more or less unbiased fashion by unbiased sensors and put out publicly so that it can be replicated. The case that you mentioned about the greenfield analysis of the carbon credits actually was quite ironically the inflation happened because of human experts, not because of Earth observation data. So in fact, the human experts who are doing the analysis made all sorts of biased decisions. And there's a recent paper we published in Nature Communications a couple of weeks ago showing there was actually humans who made the mistake and the AI that found the mistake, or the Earth observation that found the mistake. So I believe that the EO community actually is far more open and reliable than the traditional sources of decision making, which is gut instinct and political correctness or political politics rather than data that's being used for making the decision. So
Thank you for the comment. Yes, the Earth observation community is more protected because there's been lots of work on the robustness of the metadata and all the principle that has been the work has been done on it. There is something. I mean, the geodata liability. If you go to finance to bank, they have also a problem, but the same. I think the same pattern is the audit of the chain of processes. On the geodata liability, I focus on the end part because of our business. But if you take another business area, you have to have a careful audit over the whole chain. And the issue generally is how you audit the black box. Thus, in banks, there will be KPI, KRI. And what I want to say in this presentation is to find some standard, to define some standard, sorry, on how to, for example, to derive uncertainties from the inputs to the output. Because, for example, if you look at some urban heat map, from commercial one, you have a map for different seasons, but you don't have a certainty associated to it, and that's and that is as a scientist, it's a problem. Thus, I believe one of the message I want to say in this presentation is that the uncertainties is as important as the mean value. Okay, but here we have to derive it from the input data to the output data. Or also, it can be used, the same uncertainties, to get more robust policies. It can be used for early warning system also. There is more, there is a broad field of application. And I don't think the message is not to not trust the AI black box. The message is to improve the output, and also improving the output. It means that the whole algorithm is going to be also improved. Thank you.
I see no other question on the floor. And I would like to do a very, very big round of applause to all our speakers for this extremely dense and interesting session, extremely valuable presentation. I think the entire ODOC, Open Data, Open Knowledge workshop today was a success. According to our statistics, we have had over 4 sessions, 210 on-site participants. So this is a gigantic result. And with very concrete and tangible advancement of the work, again, co-created, co-developed, community-based and trusted. So we're very, very proud and very thankful for all your active participation. This is extremely valuable for us to keep going and advance our work. Do not forget, the GEO infrastructure will be for information at the plenary. If you are part of any delegation, do support the continuous work towards that direction. The in-situ data strategy will be for decision at the plenary. Do support it for us to move forward and have trustworthy output data from wherever. Thank you very much.